Testing audio. Okay. Good morning, all. Online students, can you confirm whether I'm audible? What about the audio? Yes. All right. So it seems students are still joining in. I'll wait for another 5 minutes and start. And for online students, you can get the route from channel. And if you are on YouTube, I have pinned a comment there. So you can go to that link and get the route. And for others, if you are on my Telegram or WhatsApp channels, you can click on that link and get the route, right? So please download the route and be ready, get ready. If you have any issues in downloading the route, please let me know through the chat box. Yeah, now I think you can download the route from the channel. So can you send it on Zoom? The thing is, I have logged into Zoom with a different device. I'll try. I'll try. And if you are not in the channel yet, worst case scenario, what you can do is drop a message to this number. Then I can forward you the link. I hope all registered students are already on channels. You can go either WhatsApp channel or Telegram channel and get it. Yeah, please download it and get ready. It's working, right? Yeah. You also couldn't find the place? Is it? What's your name? Name? You didn't call me, right? Ah. So in WhatsApp channel, it's not open. No, no, it's available. It's available. It's working. It's available and it's working. You on the channel, right? Can you go there? Yeah, if there's anyone who has downloaded from online students, one of you can put it to the main chat. That is totally fine. That is fine. The thing is, I have used two devices to log into Zoom and for the documents. That's the thing. Yeah, thanks, Noah. Yeah, now that is on the Zoom chat as well. That is on the Zoom chat as well. For the students who are on YouTube, please go to that link I have pinned there and get it downloaded. It's working, right? Okay. Okay then. I think now it's fine. Yeah, all right. Okay. Okay, it's a holiday, right? It's a holiday. Is it a festival for Muslims? Is it Muslims? All right, let's start. Yeah, it's 8:45 now. Let's start. Okay, now most of you have joined. All right, let's start. Okay, good morning again. Today here you are here with the mechanics practical seminar, right? Mechanics practical seminar, and here today's plan is this. Listen. Today's plan is, we have how many practical sessions or experiments in our syllabus? No idea. Online? How many experiments we have in our syllabus? According to the last revision means last revision was done in, official last revision was done in 2019 with the syllabus change. And recently, like 3 or 4 months back, there was another revision done. Yeah, it's 42. Yeah, some says 45. No, 45 is before 19. 38. Yeah, some of you have updated. Good. Yeah. In the practical guide, if someone is using the practical guide issued by students on Zoom, if it's possible, please drop your messages to the main chat, because the thing is, now in yesterday's class also I told you that if you put me a direct message, it creates a separate chat box and I have to go into that chat box to check your message. But otherwise, if there is on the main chat, at a distance also I can see what you have put. Otherwise, it goes into a chat box and it's inside the box, right? So therefore, if it's possible, put in the main chat. Otherwise, I'll go there and check it. Yeah. Now, if any one of you is using the practical guide, practical resource book issued by NIE, what is NIE? National Institute of Education. There we have 42 updates, 42 practicals with the last update. Last update in the sense 2019, back in 2019. So there we have 42. That was the last official revision did. And then recently, like 3-4 months back, there were 3 practicals removed. In those practicals, mercury is used, right? So due to something, practicals related to mercury, right? Mercury හොයාගන්න නෑ. එහෙම case එකක් හරි simply mercury is not available, right? In school labs. That's a problem. ඒ case එකකින්ද මේ mercury තියෙන ටික අයින් කරා. එතන තව 3ක් අයින් වුණා. Now it's 39 actually. 38 නෙමෙයි 39. Now it's 39. Right? Yeah, that's the thing. 45 නෑ කොහොමද? ඒක කලින් revision එකේ අයින් වුණේ. It's 42. If you need, you can download it. Just Google NIE GC A level practical guide or practical resource book, right? Then in this link that will be available, www.nie.lk, National Institute of Education. From here you can get all the resource books, right? Now usually bio students know this because they need the resource book. For sure they need the resource book. Unlike the other subjects, it's a must to have resource book for bio students. So therefore, usually they know that. Now if anyone don't know, to get any resource book in A levels, right? In A levels, not in science stream, in any stream, if you need to get any kind of a resource book, practical resource books or any other resource books, you can go here and download them free, right? Okay. Okay, so what I was explaining was, now in the revised one, even though we have 42 practicals listed in the last revision, now it's only 39 will be done after this year. After this year, in the sense 25 onwards. 25 onwards, right? So therefore, now from these removed 3 practicals also, you won't be getting questions in 26 exam, even if that's 25 again, right? For sure, 27, 26 and beyond, no questions are coming, right? So today's plan is this. Now, when it comes to our experiments, basically we can classify or categorize the given experiments to few categories based on the unit, respective unit, right? Now, as an example, first four experiments are under unit 1, measurements. What are the first 4 experiments? That we have discussed already. This is mechanics practicals. What are the first 4? Vernier caliper, micrometer screw gauge, instruments other than sperometer and traveling microscope, right? Those are the first 4. And 5, 6, 7, 8, 9 are for mechanics, right? Mechanics selling and then oscillations and waves. There are 12 from oscillations and waves, 12 experiments from oscillations and waves. And again, there are around 8 experiments from thermal, and then current, electricity, and electronics. So likewise, those experiments can be categorized based on the respective unit, right? So today, what we are planning to discuss is all experiments listed under mechanics, right? All the experiments under mechanics will be covered today. Yes. As you couldn't find place. Okay, just go and come. Right. So that's the plan today. The plan is we'll be finishing the discussion of all mechanics experiments. Okay. Now let's start. Okay. Go to the first page of the Tute and listen, students. I recommend you to use a separate book or separate sheets to take down the note, because now in the Tute I have given you just a limited thing. Limited in the sense I have given you the most important facts only. But in the discussion, I'll be discussing all the required things with everything in a comprehensive manner, right? So therefore, what I recommend is to you to use a separate book or separate sheets, and you can do all the things regarding these practicals on that book or on that on those sheets. And if you did on sheets, what you can do is you can finally attach that to the Tute I have given, and you can finish this off. Right now, after today's lesson, after today's session, definitely you will be able to do any question and answer any question using these experiments we discuss, right? So if you are in the class, if you were in the class from the beginning, right, I can assure that you will answer any question from these practicals after today's session, right? So therefore, be with the session from the beginning and make yourself comfortable, especially if you are an online student. So don't try to go here and there when the session goes, right? Be comfortable with yourself. If you need a water bottle, you can keep it near, keep it close by. If you need some snacks, you can keep it there. So likewise, make yourself comfortable, right? For physical students, that doesn't matter, because you can't, like, you don't go out like here and there, right? Okay. Right. I hope it's clear. So any other questions before starting? Any other questions before starting? Anything to clarify? Is there anything to clarify before starting? All good? So spend this holiday effectively, right? This is a holiday you have got, and for me also, since it was a holiday only, I got this chance to do this session, right? Theory class students know that I have been searching for a day to conduct the practical seminar, and I couldn't find a date because I wanted to take like 5-6 hours straight to cover all practicals, right? Otherwise, it's I mean, I don't need to do it as first 3 practicals on one day and the remaining 3 on another day. So that's why I wanted to take a slot of like 5 hours, 6 hours straight, right, to cover everything off. Okay, now because of this holiday, only I got a chance to conduct this session today, right? Now, otherwise, if it was an evening hour, it's not going to work, because now if you come to the class after school, I have to start the class maybe at least 3 or 3:30. Then if I need to take 6 hours, then it will be like 9:30 when it ends. Then there are transportation issues, especially for the physical students, right? Can I get a non-Telegram link for group? It doesn't matter whether you are on Telegram or not. If you click on that link, you can open that link from any browser you are using, maybe Google Chrome or anything. Open that link from any browser, then you will be directed to that file, right? Telegram තියෙන්න ඕනේ නැහැ. Right? Telegram තියෙන්න ඕනේ නැහැ. Just click on that link or open that link from any browser you are using. Google Chrome or Safari or Mozilla Firefox or anything. Any browser you are using, open that link. Then it will be directly navigated to the file. Can we manage without the hard copy of the Tute? Yeah. The thing is, the Tute is given just for your reference purpose, right? And we'll be writing everything down, because in the Tute, I told you at the beginning also, in the Tute, I have just included all the important facts only. Important in the sense, the minimum facts. I have included only the minimum facts, right? So that is not the thing, that is not the whole thing that you need to know for the practical, right? So therefore, you will be writing everything down, you will be taking down all notes with me here, and you can keep it as the main note, right? Otherwise, Tute is just for your reference purpose with the most important facts. Simply, in the Tute I have given what is there is a summary. It's a summary. ඒක තියෙන summary එකක් විතරයි. හරි. practical එක තියෙනවා complete. method එක තියෙනවා, practical එක තියෙනවා, apparatus තියෙනවා, සේරම තියෙනවා, but it's a summary. It's a summary. Right? So I have included them in a shortened form. Right? And actually, that's the exact thing that you can find in the practical guide provided by NIE. But just by going through it, right? Sometimes you don't get what is done in the practical with that description given. The thing is, that is just a summary, right? So that is why we have to take down another note, a separate note on the practical. All right, let's start. Okay, practical number 1. Let's start. Take down the heading. Practical 1. Verification of, write down, take down the heading. Verification of law of parallelogram. Verification of law of vector parallelogram. Take down the heading as verification of law of vector parallelogram. Right. So before moving on to the experiment, first let's recall the theory part of vector parallelogram. Right? Coming. You can come to the front if needed, right? If you couldn't see the board, you can come to the front. Right. Can you pass it? Okay, so we are in the first experiment, first practical. Take down the heading as verification of vector parallelogram, law of vector parallelogram. Verification of law of vector parallelogram. About breaks. About breaks. Yeah, during which time the Muslim students has to go to pray? Can anyone tell me the time? You know, 1:30. Before 1:30. 12:30. 12. You mean 12:30 to 1:30? I mean, right. 12:30 to 1:30. Right. Okay. Then the plan is this. Listen. Plan is this. Listen. What if now it's 9 almost? What if I continue straight up to 12:30 and give you a break from 12:30 to 1 and then continuing the rest? Or that's a one break of 30 minutes. Or I can give like 2 breaks of 15 or 20 minutes. What's better? I mean, for physical students, that would be fine. But for online students, sometimes when you are in front of a screen for like 3 hours, 3.5 hours, 4 hours, sometimes your focus will be like losing. That depends, not for all. Yeah, what's your preference? First plan is I can continue this straight up to 12:30 and will be giving a break of 30 minutes, right? We'll be giving a break of 30 minutes. Then you can come back to the class at 1, right? 30 minutes is enough to go and pray, right? So you can go pray and come. Is that only for boys? All right. Yeah, I should go for mosque. Then 30 minutes will be enough, because we'll be finishing the session. I have planned to finish by 2:30, but if you do these things some kind of in a faster manner, like around 2 or something, let's try. We'll see. That depends on your speed. That's enough. Yeah, it's enough, ne? Okay, we'll go with that plan. Right. Okay. Take down the heading, verification of law of vector parallelogram. Right. So before the experiment, this is the theory part you need to know. See, this is a theory related to this. Now you have learned the theory of vector parallelogram in vectors, right? How many vector laws we have? How many vector laws we have in our syllabus? I'm just recalling you the stuff we have. Doesn't work for me. You mean the Telegram link? Can you drop me a message to this number? WhatsApp, only WhatsApp. Yeah, how many vector laws we have? 1? More than 1? No idea. 3? So is this for the 27 batch too? Actually, the focus batch is 26, but that's fine. For 27 batch also, vector parallelogram is done now. And now 27 batch, we are starting linear momentum today, right? So that is fine. Because anyway, you need to learn these things one day, right? And more earlier you can learn, means more comfortable you are with that particular part when you go to the exam, right? So therefore, that's fine. That's why I shared that in the 27 group as well. That is fine. Since we are explaining from the scratch, so even though you don't know that particular theory part, you will get an idea after the explanation. 3. First one is vector triangle. Then vector additive law. Vector triangle law, vector additive law, vector parallelogram law. 3. Right? 3 laws. So it's okay. Right. The theory is this. Look at the board. If we can represent, look at the board. If we can represent any two vectors, let's say P and Q, if we can represent any two vectors P and Q using two adjacent sides of a parallelogram. Right? Now, if these two are two adjacent sides of a parallelogram, to complete this parallelogram, we can draw another vector which is equal to this length here. That's a parallelogram name. We know parallelogram is a equal and parallel side length. See, and here, say this is P. This is P. The diagonal which goes through these forces. See, the diagonal which goes through these forces. How many diagonals for a parallelogram? How many diagonals for a parallelogram? Oral maths. Only two. Only two. Right? One diagonal goes through these vectors. This is one diagonal which goes through vectors. Right? So this is given, this R is given by, or the other words, this diagonal is the resultant of these vectors. Vector addition. Vector addition is given by the diagonal. This is a theory. Right? And there's another diagonal, and that diagonal gives us the vector subtraction. Right? So that's a specialty in parallelogram. Using triangle, we can only get an addition, but using parallelogram, we can get both addition and subtraction using the same parallelogram. Now, verification is only for the addition. The reason is this: if it works for addition, subtraction is a negative addition. Definitely, it works for a negative addition, right? Now, in reality, in real maths, we don't have four mathematical functions as addition, subtraction, and multiplication and division. Only two. Only two mathematical functions: addition and multiplication. Division කියලා එකකුත් නැහැ. Division is the multiplication with fractions. Right? Division කියලා කියන්නේ multiplication with fractions. So likewise, subtraction is the addition of negative numbers. හරි? අපි අර subtraction කියලා ලේසියට කිව්වට ඇත්තටම ඒක same function එක. That's the same function. Right? Okay. So therefore, this is what we are going to prove. Now, if we can represent, listen again, if we can represent two vectors P and Q by using two adjacent sides of a parallelogram, right? The diagonal which goes through vectors gives us the resultant of vectors, right? That is the theory. Now, what we are going to prove here is, verify here is, whether this actually works out, right? Using some masses, known masses, we are going to find this out, and once it is verified, then we can use the same setup to find the mass of an unknown object as well, right? So we'll see how it's done. Okay. Did you get the root? Not yet? Okay, I'll check. Take down this one first as the theory. Take this down, then I explain. Under the heading, as the theory, explain this first. Take this down first, then I'll give you the theory. Take it down. Use different colors if needed. And I hope you have an idea that vector addition and numerical addition are two different things, huh? Right? Sign එක දන්නවනේ. This notation is for vectors. These two are different, huh? 3 plus 4 and vector 3 plus vector 4. These two are different. What is 3 plus 4? Yes, come. You also couldn't find the place? You couldn't find the place? Okay, that's fine. We have just started. Take down the heading and take this down. 3 plus 4. What's the answer? 7. Vector 3 plus vector 4? It's actually 5. This is like this kind of a scenario. 3 newtons, 4 newtons. The resultant is 5 newtons. Right? So vector addition and the numerical addition are two different things. Math students know this. You have done vectors, right? So that's why this notation is put to say that it's a vector. And if you are representing a vector using 2 letters, we will be using another different notation. What is that? If we need to represent a vector as this using 2 letters, we are using this notation, right? To represent a vector using a single letter, this notation is used, right? So we have discussed these things. I'm just recalling. Okay. Finished. Okay, below this, write down the theory. Write down the theory. Use a red pen and write this down. 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 If any two vectors, if any two vectors can be represented using two adjacent sides of a parallelogram. Two adjacent sides of a parallelogram. Two adjacent sides of a parallelogram. Yeah. Two adjacent sides of a parallelogram. The diagonal which goes through vectors. The diagonal which goes through vectors. The diagonal which goes through vectors. The diagonal which goes through vectors represents resultant vector. Represents resultant vector. Goes through vectors represents resultant vector. The diagonal which goes through vectors represents resultant vector. Right. Yeah. So please be active in the class. The reason is now like this I'll be discussing everything from scratch. Right now, otherwise now in the Tute I haven't put this Tute මං කිව්වා Tute එකේ තියෙන්නේ නිකන් summary එකක් විතරයි. And that's the exact details that you can find if you download the resource book from NI. Right? ඒකේ තියෙන summary එකක් විතරයි. But just by going through that, sometimes you won't get the whole picture. Right? So that's why we need to explain, we need to discuss these things in a comprehensive and in-depth manner. Right? Now, even though this is a holiday, now you are here because of you have this dedication, you have this need of learning this. So therefore, please be in the class. Please be active in the class. Always when I ask something, doesn't matter whether you are on Zoom or YouTube, I can see both chats. You can engage answering, right? Because I need to engage you with answering, because then I can get an idea whether you are actually here or have you understood or not. You are on the track simply, right? Okay. So what's that? Oh, yeah, that's the intersection point. Point O. Right. Look at the board. Look at the board. Don't write anything. Just look at the board. In our school labs, this setup is available, right? This is a setup. Setup in the sense is called the setup of or the apparatus of vector parallelogram or setup of vector parallelogram, right? This is a board. To this board, two pulleys are fixed, right? ඒක already තියෙන setup එකක්. Strings දාලා නැහැ, masses set කරලා නැහැ. මේ setup එක තියෙනවා. හරිනේ? school lab එකේ මේ setup එක තියෙනවා. අර නැත්නම් ඉතින් අපි මේක මේ class එකේදී නිකන් හදාගන්න බෑ. I mean it's possible but it takes time. මේක frictionless විදිහට හදන්න ඕනේ. ඒක lazy නෑ. Right? මේක setup එකක් තියෙනවා. These are already having set up in any laboratories. Right? මේ තියෙන board එක. This is a wooden board. Onto that wooden board, two pulleys are fixed. Right? And what we need to do is we have to have two strings. Right? Listen. We have to have two strings, and I'm going to connect these strings like this. I'm going to connect these strings like this. And if I draw the exact thing that you see in school, and for this string we have to connect a pan. You know what a pan is, right? Like a balancer. Balance එකේ තියෙන pan එක. Not pan balancers, අර normal balance එකේ තියෙන pan එක. Like this to put something in, right? So such kind of pans are there. Small pan එක මෙන්න මේ වගේ. Very small pan, right? අන්නේ pans මේකට connect කරනවා. So it's actually like this when the pans are connected. Right? Okay, now how many strings are here? No, only two. Only two. This is a single string and this is another string. Only two strings. Right? Now, if I have hung something using a middle point of a string, it comes down. So that is what has happened here. That's the same string. This is the same string. This is the second string. Right? Only two strings. Only two strings. Okay. Now, we have to have three known weights first. Three known masses or three known weights. Right? Three known weights. This is important. Three known weights. Three known weights. Three known weights. Right? මුලින්ම unknown weights අරගෙන මුකුත් කරන්න බෑ. If this is verified only, as the next step, we can find the unknown weight. Give me a second. I haven't disabled the whiteboard sharing. Someone is using the whiteboard. Okay, now I have disabled. Okay. Right. If you have any questions, you can put to the chat. Otherwise, now, if you are putting like unknown things, I'll block you from the chat. Then you can't put any messages until the meeting is ended. Right? So it's up to you to decide. Right? There are options. There are options, and now if needed, I can block you from my Zoom account. And if I block you from the Zoom account, you can't join into this Zoom account meetings again until I unblock you. So likewise, teachers are there. Just put the academic stuff, or if you have any questions, to the chat box. Reactions are fine. Right? And if someone has asked a question, if any one of you know the answer, that is totally fine. You can answer, because now I'm always saying in classes, this is not a individual thing, right? You have to go through the exam as a group. That is better, right? Otherwise, individual competition is not always good, right? Now, when it comes to universities, that environment is not there. In universities, always like we are trying to go through as a batch. That attitude is, it's like a nice attitude, right? Because the thing is, now if there are like repeat students in the batch, right? Let's say now from the batch, 10% or this kind of percentage is repeat of students are repeated, then there are some cases where then whole batch is not getting the chance to go for the convocations, right? So therefore, always learning as a team, learning as a group is encouraged there. And that's a very good approach. Unlike A levels, you will see that difference. That's a huge difference when you go to universities, right? In state universities, that is at the top level, and in private universities also, that is they are up to a certain level, right? In state universities, that is at the top level, right? සමහරවල් ලෙක්චර් එක තේරෙන්නේ බැච් එකේ එක ළමයෙක්ට විතරයි. ඒ ළමයා ඊට පස්සේ බැච් එකටම කියලා දෙනවා. ඒ වගේ කේසස් හොඳනම් තියෙනවා. එහෙම තමයි ගොඩ යන්නේ. Right? So therefore, learning as a group is highly encouraged. So therefore, now if I didn't see your question in the chat, and if any one of you know the answer, feel free to send the answer if you are confident enough about the answer. That is totally fine. And I don't mind whether it's correct or wrong. If I saw it whether it's wrong, then I'll correct it. No, otherwise, you can share it among yourselves, because now all of you are here to achieve a same goal, right? මෙතන A levels කරන්න විතරනේ කොහොමද තින්නේ? A levels කියන්නේ A level physics කරන්න විතරනේ. Right? That is fine, nah? Okay. What I was explaining was, now first we have to have three known weights, right? Three known weights. So let's say the weights are W1, W2 and W3. This is W1, right? Or else you can write this as M1G. So straight away I am taking the weight as W, right? W1, W2 and W3. Three known weights, right? Now, if this system is in equilibrium, right? If this system is in equilibrium, if I think of this point here, look at the board. Let's say point O again. If I think of this point again, if the system is in equilibrium, this point is also in equilibrium, no? Right? And there's another theory you need to know. There's another theory you need to know. If any object is in equilibrium under three non-parallel forces, if any object is under equilibrium, in equilibrium under three non-parallel forces, all three forces intersect at the same point. And there we discuss 5 features, right? We have 5 features. If you have these kind of forces, we discuss in equilibrium. Resultant of any two reactions, or resultant of any two forces should be same in the magnitude, equal in the magnitude to the third force and opposite in direction. It makes sense, no? Because now if this is in equilibrium, total resultant has to be 0, right? If this is in equilibrium, total resultant has to be 0. So therefore, let's say the resultant of these two is R, right? Then if I can narrow down the resultant of these two as R, then only two forces remains. If a system is in equilibrium under two forces has to be parallel and opposite, right? It should be parallel and opposite, and that means at the same point. Otherwise, if the point is different, it creates a force moment, right? So therefore, R and this remaining force has to be equal. This works for any two forces. So therefore, if any object is in equilibrium under three non-parallel forces, resultant of any two forces is equal to the third force and opposite in direction, right? Now, let's mark the forces acting here. Okay, tell me, how many tensions are here? How many tensions in this system? How many tensions? How many different tensions in the system? How many different tensions in the system? Now for this experiment, listen. For this experiment, we are considering light strings. Light strings in the sense, පුළුවන් තරම් thin strings තමයි ගන්න. Ropes වගේ ඒවා ගන්න බෑ. Then it won't be light නේ. So therefore we are using light strings, very thin strings, such that we can neglect the mass of the string. So they are light strings, right? You can always assume them as light strings, right? And these pulleys are also frictionless. We have a method to check it out whether it's having friction or it's frictionless, right? I'll explain it later after explaining the theory part. Yeah, how many different tensions? Tell me. 3. One says 3. Others? I heard something. 4. 5. How many different tensions? I'm not asking about terminal tensions or something. How many different tensions here? How many different tensions? 2. What do you say? 3. Same. 4. 3. It's actually 2. Yeah, it's 2. It's actually 2. Because tension changes if the string changes only. For a given string, tension remains same. For a given light string, tension remains same. Right? Tension changes if and only if the string changes. Or it should have intermediate obstacles like this. Straight string ega the same tension ega. See, now if I mark these tensions, it will be like this. Let's say this is T1, right? Up to here there is T1. Up to here there is T1. And that side also there is T1. Then up to this point there is T1. Right? And after this point it changes. Let's say T2, T2, T2 and T2. Now on this string, we have two different tensions. On this string, we have two different tensions, right? And if I mark the tension on the other string also, right now, first I asked about this one, only two different tensions. And then about the second string, there is another one tension, one different tension. So altogether, it will be 3 tensions, T3, let's say, T3, right? So altogether, it's 3 different tensions. Understood? Now, these 3 different tensions are, see, it is like this. Now, this point is in equilibrium under 3 non-parallel forces. Then, simply, the resultant of T1 and T2 should be equal and opposite to T3. Right? Otherwise, it won't be in an equilibrium. Okay. That is what we are going to see now. Okay. First, I need you to take this down. So, before taking down, let's mention about the apparatus and the instruments we are going to use. Right? Then I'll explain the method. I didn't explain the method yet. This is just the setup. Then setup කරගෙන තියෙන්නේ. setup එක කරගෙන තියෙන තාම experiment එක කරේ නැහැ. මෙතන setup එක. ඒතර lab එකේ මම කරන්නේ board එක විතරයි තියෙන්නේ. masses වෙනම තියෙනවා. You have to get these masses and you have to tie them with these strings and make this setup. Right? Strings දෙකක් ගත්තා. masses ටික ගැට ගහගත්තා. setup එක හදාගත්තා. Right? නැත්නම් මේක already setup කරලා නැහැ. Rarely in some schools මේක නිකන් wall එකක වගේ fix කරලා තියෙන්න පුළුවන්. අන්න එහෙම නැත්නම් setup කරලා තියෙනවා. සමහරලාට එහෙම තියෙනවා. Right? I have seen in some schools. Now, since this is only used for vector parallelogram, this setup is fixed to a wall. Then anyone can use it at any time. That is fixed to the wall, and in that case, the strings are already there, also there. If that is fixed, otherwise, if this is inside a cupboard or something, this is not set up. Then we have to take it out from the cupboard and you have to do this setup, right? Okay. Okay, then as the next stream, first write down materials and apparatus. Heading. Materials and apparatus. Materials and apparatus. Next heading. Materials and apparatus. Materials and apparatus. Okay. First, I'll mention all materials that we need for the experiment. And I haven't explained about some of the materials yet because this is just the setup I explained. Right? So first mention these materials one by one. First materials, First materials, one by one. First one, 3 known weights. First one, 3 known weights. So why have we tied the W2 mass with both strings? No, that is to create 3 non-parallel forces because we have to have 3 forces like this to verify vector parallelogram, to verify the law. So that's why we are creating it. දෙකක් විතර තිබ්බොත් verify කරන්න බෑනේ parallelogram එකකට දාන්න. Right? So we have to create it. That's why this setup is used. Yeah. Right? First one, 3 known weights. Second one, apparatus of vector parallelogram. Apparatus means this. This entire thing is called the apparatus. Apparatus of vector parallelogram. Next. Now this comes with not the verification. Now I told you before that after the verification we can find a weight or the mass of an unknown weight, unknown mass. Right? For that also we have to have a small stone or a glass stopper. Glass stopper කියන්නේ මොකද? Stones, දන්නවනේ. You know stones. Stone එකක් ගන්න පුළුවන්. Glass stopper. What are glass stoppers? Glass stoppers කියලා කියන්නේ අර සමහර bottles වල එන්නේ මේ උඩ lid එකක් glass වලින්. ඒක glass stopper එක කියලා කියන්නේ. අර මෙහෙම ගහන lid එකක් කියන්නේ not to like rotate and release. අර glass වලින් එන lid එකක් තියෙන. අර අනිත් එක නෙමෙයි. That is called glass stopper. Right? Glass වලින් එන lid එකක් තියෙනවා. Right? ඒක lab එකේ තියෙන ඒක ඒ කියන්නේ glass lid මේ glass stopper එක ගන්න බෝතලයක් ගන්න ඕනේ නැහැ. ඒක වෙනම ගන්න පුළුවන්. Right? Apparatus of vector parallelogram. Then small stone or glass stopper. Glass stopper again, glass lid එකක්. Glass stopper. Right? Then a set square. මේ දෙක එකක් තිබ්බනම් ඇති. A set square, you know what the set square is, right? A set square or a small mirror strip. Small mirror strip. A set square or small mirror strip. Then half meter ruler. Half meter ruler. Then a white sheet can white paper එකක්. A white sheet. Right? Then pins. And last, we have to have a balance. So we can use either a triple beam balance or an electronic balance. Right? Last one, triple beam balance or electronic balance. 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 Right. Okay, now again take down a subheading as apparatus. Subheading as apparatus. Subheading as apparatus. Take down a subheading as apparatus. Take down a subheading as apparatus. And now take this down in a clear manner. It should be very clear to you. So you can use different colors. that brown wooden thing. No, not the wooden one. Not the wooden one. Glass වලින් එකක් එනවා. මම ෆොටෝ එකක් ඕනනම් පෙන්නන්න. මේ ඒක ලැබ් එකේ තියෙන්නේ wooden එක මේ يعني it's too light. එතකොට අපිට ඕනේ weight එක එන්නේ නැහැ. wooden එක use කරන්න බෑ. Right? No, I don't think it's visible. මේ තමයි glass top එක කියලා කියන්නේ. Right? අර wooden එකම තමයි ඒකම glass එකක් තියෙනවා. Right? Wooden one is too light. ඒ වගේක් මෙතන use කරාට මේක මේ පාත් වෙන්නේ නැහැ. එතකොට අපිට හරියට experiment එක කරන්න බෑ. It's too light. Glass toppers are available in lab. කියන්නේ අපි bottle එකක් අරගෙන glass topper එකක් හොයාගෙන යන්න ඕනේ. It's available in the lab. It's already available in the lab. Finish? Keep this note with you. Keep this note secured with you until your exam, because today I'll be discussing everything you need to know. Right? You won't get any question beyond what we are discussing today. Right? So therefore, prefer this as a final note, a complete note for any question until your exam. Right? If you are using sheets, attach them to the Tute later and keep it secured. And for online students, if you need to get a hard copy, you can get that PDF and get it done from any print shop, right? Okay, finished. Right. Listen. Now I'm going to explain the method. Listen, this is the most important part in an experiment. Method. Method means this is the core of the experiment. Method එක තමයි ඕන experiment එක දැනගන්න ඕන part එක. I mean, the part you need to realize, you need to understand in any experiment is the method. Right? Knowing theory is just a fact. Knowing theory doesn't mean that you know the experiment. We have to know the method. Then only we can connect that theory with the method. Right? That is what we do in an experiment. මොකක් හරි තියෙන theory එකක් prove කරන්න experiment එකක් තියෙන්නේ. නැත්නම් අපි අලුත් theory එකක් හොයාගන්න experiment කරන්නේ. Right? We are going to prove, verify a theory that is already existing. Right? So therefore you have to know the theory. That's why we discussed about the parallelogram. That's a connection here. And now we are going to use a setup, some kind of apparatus, and going to check whether it's correct. So therefore knowing theory is it's a basic, it's a fundamental thing. Right? So knowing method means, understanding method means, then you will see the logic behind the method and the links with the theory of this method we are using. Then only we can come to the conclusion later. Right? The ultimate result of any experiment is a conclusion. Right? Then at the conclusion, we should be able to see whether it's verified or not. Right? It should be verified. That's the idea. Okay, first thing is this. Now, we have a white sheet. No? We have a white sheet. A white sheet. Usually A3 size. Okay? It's like A3. It should be, this is usually larger than A4 size. So therefore, this sheet should be like A3 or A2 or something like that. Right? First, we have to take that sheet and before this strings are put onto this, before these strings are put onto this, we have to fix that sheet here onto this board, using pins. We have pins, huh? Yeah, pins. We have pins, right? So using 4 pins. Have you heard about drawing pins? Drawing pins So usually we are using drawing pins. And on this board, to make it easier, this part is made of rigiform. Okay. This is actually a wooden board. In front of the wooden board, a rigiform board is also fixed to make it easier to fix pins. Right? So therefore, this is a rigiform part. මේ part එකේ කොහොමද තව rigiform එකක් තියෙනවා. නැත්නම් අර දැන් wood එකට මේක ගන්න ගියාම අමාරුයිනේ. Right? So therefore, that's there in the setup. It's already there in the setup. So take that sheet. Take that sheet. This is a white sheet. This is a white sheet. And we are fixing that white sheet onto this using these pins. 4 pins. Like this. Right? And then you have to complete this setup. You have to complete this setup. Now what we have is the white sheet at the back. Right? White sheet at the back. And in front of the white sheet, 2 pulleys. And this setup is hanging. Right? And before starting the experiment, we have to check whether these pulleys are actually frictionless or not. Right? It should be frictionless. I mean, it's supposed to be frictionless to get an accurate result. So therefore, now before doing the experiment, we will check it. Otherwise, if there is having friction, if there is not frictionless, our results may be inaccurate, not accurate. Right? So therefore, for that, what is done is this. Now, after the setup is done, this middle mass at the center, this mass is dragged down and released. This is dragged down and released. Right? So once it is dragged down and released, if it is coming to the same point it was before, to the initial point. Now, initially, say it's here. Now we are dragging it down like this and then released. Again, if it's coming back to this point when resting, which means there is no friction. Right? Same energy. Same energy. මෙතන තියෙන energy එකම මම drag කරලා ආයි තිබ්බත් තියෙන්න ඕනේ. According to law of conservation of energy. That's a logic. That's a logic. Right? So therefore, that is what we do. මැද එකෙන් විතරයි අදින්නේ. මෙහෙන් අද්දුත් එimhe setup එක imbalance වෙනවා. Right? අර එහෙම කැමති එකකින් කරන්න බෑ. Drag this down and release. And check whether it is coming back to the same initial point or not. If it is coming back, there is no friction. If it is not, there is friction. If there is friction, you have to apply lubricants to these 2 pulleys to make it frictionless. Right? So ඒක decide කරන්න ඕනේ before doing the experiment. Experiment එක කළා මේක check කරලා වැඩක් නැහැ. එතකොට ඉතින් result එක ඇවිල්ලා නැහැ. Right? So therefore, as a precaution, we do it. Right? So if not, we can use lubricants here, lubricant oils here, and minimize friction. Right? Now, let's say it is coming back to this point. Everything is working fine now. Everything is working fine. Right? Okay. Now, these 3 are 3 known weights. No? These 3 are 3 known weights. So therefore, let's say this weight is W1. Then what's the value of T1? Anyone? What is T1 in terms of these weights? What is T1 in terms of these weights? Engage answering. Is this system in equilibrium? Yes. This is a system in equilibrium. Right? If there is a system in equilibrium, we know 2 conditions are satisfied. Right? One is resultant force along any direction will be 0. Or resultant force moment about any point of the system will also be 0. Right? Now here there are no moments, but you can check forces. What is T1 in terms of weight? Very simple. T1 equals W1. T1 equals W1, vertical equilibrium. This is in an equilibrium. If the system is in equilibrium, the entire system is in equilibrium. Right? Point at equilibrium again. If the system is in equilibrium, all the points in the system are in equilibrium. So this weight is also in an equilibrium. T1 equals W1. Right? And T2 equals W3. Right? But we don't know about W2 equals let me mark the other way, that will be easy. I'll mark this as T3, yeah? T3, 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 then T3 and W3, and this is 2 kilogram. Nothing, notations pattern. Right? That's fine. T1, T2, T3. And T2 equals W2 and T3 equals W3. But still, we don't know the relationship between T1, T2 and T3. Right? But for sure, we know that the resultant of T1 and T3 has to be T2 in terms of the value, and it should be opposite in the direction since this is in equilibrium. Equilibrium කියන එක හරිනේ, we can see it by our own eyes. If there is not an equilibrium, it should be accelerated. So the system is not accelerated. System is at rest. So that is an equilibrium, right? So therefore, now we know there is a relationship between T1, T2 and T3. And actually T1 is W1, T3 is W3, and T2 is W2. Which means tensions are known. Because these three are three known weights. These three are three known weights, right? And when we select these three weights also, we have to have three weights which are like approximately equal. ඒ කියන්නේ ලොකු ඩීවියේෂන් එකක් තිබ්බොත් එහෙම මේක බැලන්ස් කරලා තියන්න බෑ. හිතන්නකො මේ පැත්තට 10 කිලෝස් විතර දැම්මා කියලා මේ සිස්ටම් එක කඩාගෙන වැටෙනවා. 10 කිලෝස් බැලන්ස් කරන්න බෑනේ මේ පැත්තේ ඉන්න නිකන් පොඩි weight එකකින්. right? පොඩි weights ආන්න ඕනේ. ඒ කියන්නේ like 230, 250, 270. Approximately equal. Equal ඒවා නෙමෙයි, approximately equal ඒවා. right? ලොකු deviation එකක් තිබ්බොත් බෑ. If there is a deviation like if you are using 100 grams with 1 kilogram, that's not going to work. මේ system එක ඒතොර මේ පැත්ත පාත් වෙනවා. right? Okay. Now come back to here. Now we know the acting line of T1 is along the string. Listen. Acting line of T1 is along the string. Acting line of T3 is along this string part. And acting line of T2 is along this string part. Right? Now, acting line is known means the angle between forces and acting lines of forces are known. Now, to draw a parallelogram, now beforehand we have to know this. Then only we can draw the parallelogram. Which means acting line should be known with the angle. Acting line should be known with the angle. Now, I'm going to find out, and we are going to find out the acting lines of these forces like this. For sure, we know that is on the string, right? So, which means we have to get the exact directions of these strings onto this paper somehow, right? For that, there are two methods. Listen, for that there are two methods. And when a question is coming, you will be questioned about these methods, right? That is how usually an experiment, a structured essay question comes. One second. When you send messages to the Zoom, if you are sending direct messages, direct them to the Machma account, right? Not my personal one. Yeah, that's the visible account on the screen. That's why, right? Okay. Now, to take this to this paper, there are two methods. We have a set square and a small mirror strip. And a set square or a mirror strip, right? Say one string is like this. If the string is like this, now behind this we have that white sheet, right? You know set square, right? Set square, right? Method one is this. There are two methods. I'll explain both. Listen. Method one is this. Method one is using set square, right? Using set square, what we can do is we can keep this set square as it is perpendicular to the board like this, right? We are placing the set square as it is perpendicular to the board like this. And we can take it closer until it just touches the string. Right? And then now using this, if I draw a line here using a pencil, using a pencil, now using a pencil, we can draw the edge here, the line here, which goes along this set square. Set square anyone has got a set square? No. You can imagine, right? මේ set square එක මෙහෙම තියන්න ඕනේ මෙතනින් ගිහිල්ලා. මෙහෙම අරගෙන මෙහෙම තියනවා. මොකෙන්ද වෙන්නේ? the set square is like this. Ne? So this side of the set square should be kept on the block like this, kept on the board like this. Right? And this is an aerial view here. Right? And we are taking it much closer to the string as it just touches the string. Right? And then using a pencil from the other side, make a contact. Now, if your set square is in contact with the string, it's going to change these tensions because some part of the tension is coming to the set square. Right? So it should be kept as it just touches, in the sense actually it is not touching. Right? Not touching, just touches. Right? And from the other side, you can use a pencil and draw that line. Can you imagine? මේ පැත්තෙන් pencil එක ගන්නවා අරගෙන දැන් මේකව මෙහෙම තියලා තියෙනවනේ. මෙහෙම තියනවා. As it just touches the string. Take a pencil and from the other side, දැන් මෙතන පොඩි space එකක් තියෙනවා. There's a small space between the sheet and the string because this thickness of the pulleys are here නේ. පොඩි space එකක් තියෙනවා. මේ space එකෙන් මෙහෙම කරලා මේක අඳිනවා. Right? Then you can mark, let's say this is the white sheet. Let me draw it here. See? Now let's say this is the white sheet we have. That white sheet. Say this is the white sheet we have. Now on the white sheet, then this direction can be marked like this. Right? And same thing is done. Same thing is done for this one as well. Right? Same thing is done for this one as well. And that direction can be marked. Right? That can also be marked. And then about method 2. This is method 1. No? This is method 1 using set square. And method 2 is using mirror strip. Using mirror strip. Using mirror strip, that is more accurate. Listen. So therefore, it's a must to you to know about the mirror strip case. That's the accurate case. Right? So using mirror strip, this is what is done. Questions? Okay. Using mirror strip, this is what is done. We are keeping the mirror strip. We are keeping the mirror strip behind the string like this. Right? Behind the string. Right? We are keeping the mirror strip behind this. And when you see through the mirror, we will see the image. The reflected image. That's a plain mirror. It is then moon mirror. Now the dressing tables are the podi mirror, podi strip, chudi strip, mirror strip. Right? Now from this mirror, we can see the reflection of this. So when you check from either sides, you will see the reflection. Right? And there is one point at where the reflection is exactly covered by the actual string. The reflection is exactly covered with the actual string. Reflection, right? Shadow reflection. That reflection will be covered at any point. You have to change the angle that you are looking at. And then at one point you will see there's a point comes as the reflection of mirror strip or the image of string on the mirror strip is covered by the actual string. Right? Which means both are coincided at that position. So there what we do is, at that position, we will mark these 2 points like this. Again, by taking a pencil, we are marking these 2 points. Right? The mirror strip perpendicular. If your mirror strip is not perpendicular also, you won't see it. So you have to rotate the mirror strip as it is perpendicular. And then when you look from the top, you will see the image is exactly covered with the actual string itself. Right? At that position, mark the mirror strip, mark the positions of mirror strip close to the string like this. And then we can take this out and connect these 2 dots. Once the dots are connected, that's the direction of acting line of T1. Right? And we can do the same, you can perform the same for T3. And again, you can perform the same for T2. Right? And for T2, once you did it, you will get something like this. Within direction, you will get something like this for T3. Right? Now, these are the three directions. These are the three directions that we have taken to the white sheet now. Right? And when we do so, white sheet should be firmly fixed onto this. It should be firmly fixed. And once these three directions are marked on the white sheet, we can take this out onto a table. Right? We can take this out onto a table. Right? Now this is the white sheet we have with the directions of forces. Right? Okay. There are a few more things to explain. So before that, we'll write the note and then come back. Right? Otherwise, if I explain everything at once, so why are we making in pencil? That is fine. Using a pencil because now if there's something goes wrong, you can erase. Simple as that. Right. Okay, then as the next heading, write down method. Next heading, method. And when you write down method, write it as one by one, like 1, 2, 3, 4 number wise, because this method is in an order. Right? I'm giving this method in an order. That's the same order you have to follow. Right? First point, first one. Fixed white sheet. Fixed white sheet. Fixed white sheet. Fixed white sheet onto the board using pins. Onto the board using pins. Fixed white sheet onto the board using pins. Fixed white sheet onto the board using pins. And number two, keep known weights W1, W2 and W3. Keep known weights W1, W2 and W3 on pans, PAN, pans, on pans. Next point. By using set square, or by using mirror strip, mark projections. Projection means shadow. Mark projections of strings on white sheet. Mark projections of strings on white sheet. Within brackets. Consider the occasion when image of string is covered exactly with actual string. Is covered or slash say coincides. This is the exact word actually. You know what coinciding is, huh? Or Vernier scale again. Covers slash coincided with actual string. Right? Next point. Remove white sheet from board. Remove white sheet from board. Remove white sheet from board and connect marked dots to extend actin lines and connect marked dots to extend actin lines of forces. Right? Next point. Measure weights of pans. And add it to known weights. Measure weights of pans and add it to known weights. Right? Listen. Now, without using pans, if you just tie this to the string, right? That is also a possible method to do, right? If you just tie the glass stopper to the string, no weight of the pan is coming. In that case, W1 and T1 are exactly equal. But if we are using pans, usually pans will be used, right? If we are using pans, pan is also having a weight, something. It's very light, but still it is non-zero. It is light, it's too light, but it's non-zero. So therefore, since we need to increase the accuracy of the experiment, right, we can weigh one of these pans using the beam balance, right? Triple beam balance. Pan ekak measure karna. And if the weight of the pan is known, now actually what happens is T1 is counterbalances to W1 plus weight of the pan. So that's what I said as add that weight of the pan to known weights. That's the idea, right? That is an approach, that is a precaution we do to acquire a higher accuracy, right? Okay, next point. Before writing next point, listen. Now we have these directions now. Listen. Now we have these directions marked here. Now, if we are drawing the parallelogram should be drawn with a scale, right? It should be drawn with a scale. So therefore, we can come up with our own scale as this space of the sheet is manageable. As it is manageable with the space of the sheet, right? Now, as an example scale, something like this. Let's say 10 grams. 10 grams by 1 centimeter. This is a scale. 10 grams by 1 centimeter. Now, T1, T2 and T3 are known forces now. Because T1 equals, now if I connect it to the pan, then T1 equals weight of W1 plus weight of pan. And T2 equals W2 plus weight of pan. T3 equals W3 plus weight of pan. Simply, T1, T2 and T3 are known weights. Now let's say T1 is 10 newtons, right? Let's say T1 is newtons. That is fine, huh? Totally fine. Let's say something like this. 1 Newton is by 1 centimeter. Now, if you know these values in newtons, you can go with newtons. If you know the values in grams, you can use grams. That is fine because even though the G changes, the ratio remains same. Right? Okay. Now, which means T1, T2 and T3 are known. And now, when we plot this respective vector, now we have to adhere to that ratio, that scale that we are following here. Right? Now, let's say T1 is 5 newtons. Then you have to draw a line of exactly 5 centimeters in length. Got it? That's the idea of the scale. Right? නිකන් කැමති ඒවා දින්න බෑ. That's the idea of the scale. Now let's assume we have this kind of a scale. Now according to that scale, we have to extend these lines according to the scale. So according to the scale, you can extend these lines like this. Let me draw this again, then you will be taking this down onto your note. Now we have this on the sheet like this, and these are extended according to the scale, right? This is a scale that we can decide based on the space you have, right? So if you have a A3 sheet, now we don't use a scale as it is like narrowing to one end of the sheet, right? We have to have a good spread. When there's a good spread, always random errors, percentage errors will be less. So therefore, we are going to use, so therefore, we are going to have a good scale as it is spread around all over the sheet. That's the whole idea, right? I use 1 Newton, 2 centimeters, 3 centimeters, that doesn't matter as long as it spreads on the sheet, right? That's a scale we can decide. And according to that scale, now we have to extend these two. Look at the board. According to that scale, we have to extend these two, right? And if these two are extended, now what we can do is you can complete the parallelogram. You can complete the parallelogram like this. You can complete the parallelogram like this. O is here, right? Now having this part is not mandatory, right? O is here, and let's say O, A, B, right? Now this is OA, this is OB, right? OA and OB, and actually these two represents forces T1 and T3. Now this represents T1, this represents T3, right? And now the parallelogram is drawn, which means these sides are equal and parallel, right? Now vector parallelogram is constructed. Listen, now this is the most important part. Now the vector parallelogram is constructed, right? If the vector parallelogram is constructed, we can find the result or no? We can find the result. Now this vector parallelogram is in the scale, according to the scale, which means now in this parallelogram, let's say this is 10 centimeters long, which means I'm representing 10 newtons there. If this is 8 centimeters long, I'm representing 8 newtons there. That's the meaning. Right? And then after doing all these things, we can connect this diagonal. You can connect the diagonal. And if the theory is correct, the diagonal should give us the resultant. If the theory is correct, the diagonal should give us the resultant. And that resultant should be equivalent to T2 since this is in equilibrium, right? So what we do is, now we have a half meter ruler. Right? Take that ruler and keep it here and measure this, right? Now let's say this was 13 centimeters long. Now once we measure this, I got it as 13 centimeters long. Convert it to the other side, which means that is 13 newtons, right? Now we know this weight because we have already measured that weight using triple beam balance. Now if that coincides with that measured value, which means vector parallelogram is verified. Already measured. Now we have measured W1, W2 and W3. They are known weights, and we have measured these spans. Now addition of W2 plus span is, let's say 13. It has to be 13. And once you measure this also according to the scale, it is coming to 13. Definitely it is 13, right? And with that, we can verify whether the vector parallelogram is correct or wrong, right? That's the purpose. දැන් මෙයා අපි known weight එකක්. අපි බලන්නේ parallelogram එකනොත් ඒ weight එක අපිට දෙනවද කියලා. Right? So if vector parallelogram is correct, what it gives is the resultant of these two. But from the equilibrium we know that resultant has to be equal to T2, right? So from vector parallelogram, from the scale, we can convert that back to the weight here, and practically you can measure these two from the balance and you can compare these two. If these two readings are equal, vector parallelogram is correct, right? There is the experiment, right? Any questions? Now, from here, the experiment is over. Now, other than that, there are some like remarks or special points to be mentioned. I'll mention all these points later. Like what's the reason we are doing all of these markings, keeping the set square or mirror strip? Set square or mirror strip. Now, without using a set square or mirror strip, just by observing a thin string by a naked eye, we can't find the correct direction. Let's assume this as a string, this as a string, right? When we try to mark the image of the string, someone may mark here, someone may mark here, someone may mark there. Right? It is not going to work. That's the thing. String string pencil string right? That's why a set square or a strip should be used. Mirror strip is the most accurate method. Right? Clear? Any other questions? So why we consider pan weights? Because the equilibrium is actually with the pan weights. If pans are not light, let's say this pan weight is M1G. So actually T1 equals M1G plus W1. Vertical equilibrium. Right? That's why. Now, if you hang it using the string itself, no need to consider pans. Right. Any other questions? All good? The ones on YouTube? Oh. So your audio keeps getting cut off at certain bits. Why is it? Is it same for the ones on Zoom as well? Let me check. Is it same for the ones on Zoom as well? The 6 pins. We have pins, huh? Yeah, we have pins. Right. So using 4 pins. No, it's working fine. I think it's something about your connection. I guess I'm not sure. But if you're on YouTube, that's rendering is like manageable compared to Zoom. It's working fine, no? Students on Zoom, is that same for you? I mean, do you also experience cutoffs of voice, or is it solid and firm? Clear? Mostly I think it's something with your connection. I guess it's something with your connection. Now I check with mine. It's working fine. All good. Okay. Mostly connection එක හරියන්නේ නැහැ හැමදාම classes වලදී මෙයා වෙනවානේ. Starlink ගන්න. Or let's change the network simply. Starlink. I'm just kidding. Change the network. If it's low on coverage. So can you explain the mirror thing again? Yeah. Listen. Now, if we keep the mirror strip, let's assume this as the mirror strip. This one. Now, if you keep the mirror strip behind the string, right, like this. Now, when the mirror string is rotated, and when you look at the string, look at the image from the top, you will see the image of the string on the mirror strip, right? Now, if the image and the actual string is coincided like this, coincided means you don't see the image when you look at it from the top, right? Which means they are coincided. Image which means image is coincided, right? At that scenario, the idea is this mirror strip is exactly perpendicular to the string. It is perpendicular to the string, right? So therefore, if you mark these 2 points on the string close to string on the board close to string, that gives us the direction of the string there, right? Correct. ඒක mark කරලා මේක අයින් කරනවා. අයින් කරාම dots දෙකක් තමයි තියෙන්නේ. So what you have on the sheet is 2 dots and then take it out and connect dots. Right? මේක තියාගෙන connect කරන්න යන්න බෑ. මෙතන දැන් string එක කරදරයිනේ. ඒතර dots එක තියාගත්තා. මෙතනින් 2යි. මේ පැත්තෙන් 2යි. Minimum 2 and when we keep dots, if we can keep dots with a kind of a significantly higher space, the accuracy is higher. What's the reason? Now, when we have 2 dots like this, look at here. Let's say you are going to connect 2 dots like this, right? Now, when you are connecting these 2, now these kind of deviations can happen. Now, even though if you are connecting using a ruler, these kind of deviations can happen. But if these dots are a little bit far, see, the deviation is minimum compared to this. Then මේ දෙක මේවා කරද්දි මේතර deviation එකක් එන්නේ. තේරුණාද? මේ dots එකක් ළඟ තියෙද්දි අපි මෙහෙම connect කරද්දි මේ බලන්න එන deviations වැඩි, angles වැඩි. dot එකේ ගෑවිලා ගියත් මේ line එක. හැබැයි dots එකක් ගොඩක් ඈතයි නම් තියෙන්නේ. මේ මෙයාම deviate වුණත් පොඩ්ඩයි deviate වෙන්නේ. මේ තරම් angle එක deviate වෙන්නේ නැහැ. Right? So therefore keeping dots at a significantly higher space as possible is better. Everything is good. Clear. So will this class upload in YouTube? Yeah, that's live streaming. So can you again show how you draw that parallelogram inside the red box? Inside the red box, this one. Now, after connecting these lines, listen again. Listen. After connecting these dots, we have extended that according to the scale we are using, right? According to the scale. Now, let's say your weights are 10 newtons and 12 newtons. For 10 newtons, 10 centimeters. 12 newtons, 12 centimeters. So, likewise, according to the scale, extend these lines. Because we know vector is a vector using an arrow is a graphical representation of a vector. Length of the arrow gives us the magnitude and direction of the arrow gives us the direction. That's the idea of a vector. If this is vector AB, the length from here to here, A to B, is the magnitude of that particular vector. And direction from A to B is the direction of that vector. Right? So same thing is used. Then if these 2 sides are completed, then complete other 2 sides as a parallelogram. මෙයාට parallel line එකක් මෙතනින් ගාව මෙයාට parallel line එකක් මෙතනින් ගාව parallelogram එකක්. මේ දෙක තමයි critical. Right? So once it's done, then finally you can connect the diagonal. Right. Okay, what's the last point we mentioned? Measure weight pans, all right. Okay, next point. What's the number 6? 5. 0.6. Right. Next point. Mark lengths of OA and OB. I have labeled them here. Mark lengths of OA and OB. Mark lengths of OA and OB. It's coming from. Okay. Mark O and OB. Mark lengths of O and OB according to according to a suitable scale, according to a suitable scale, according to a suitable scale, as weights and lengths are proportional, as weights and lengths are proportional. Now, as an example, take this down. This is an example. This is not a rule. This is an example. According to your sheet, size of the sheet and the space you have, you can manage this. Right? Take this down as an example. Example 1 Newton by 1 centimeter. That is an example scale. That is an example scale. 1 Newton by 1 centimeter. A possible example scale. Next point. Next point. Label this point as C. This point as C. Okay. Next point. Complete OACB parallelogram. Complete OACB parallelogram. Complete OACB parallelogram. Complete OACB parallelogram. And connect O and C. And connect diagonal O and C. And connect diagonal OC. O and C and connect diagonal OC. And connect diagonal OC. And connect diagonal OC. For the same point, measure the length of OC. Measure the length of OC. Measure the length of OC. Right? Measure the length of OC. Right. Next point. Next point. Use a red pen and write down with an asterisk mark. Compare the weight, compare the weight comes from scale. Compare the weight comes from scale. Compare the weight comes from scale. Compare the weight comes from scale with the actual weight of, with the actual value of, with the actual value of T2. With the actual value of T2. With the actual value of T2. And verify law of vector parallelogram. Verify law of vector parallelogram. And verify law of vector parallelogram. Right. Okay, now take this down. You didn't take this down, right? Take this down. This one, no? This one. This diagram. This diagram. Only this part, this diagram. Any other questions? So, sir, by looking at OA, we are drawing its opposite side. I didn't get your question. You have to get the direction or the image of the string onto white sheet. Do we need to draw diagram? You asked about that. That's what we are doing now. So what's that? M1G and W. M1G is the weight of the pan. M1G, weight of the pan. See, this is the known weight we have considered, and M1G is the weight of the pan. Weight of the pan. So will you please repeat the point? Sorry, I didn't see which point. So we get down the first step. No, I know you have obeyed the first step. I mean this one. Right? This one. Completing the parallelogram. Okay, what about the ones on YouTube? All good? Any questions? How's your holiday so far? Okay, now the first one is done. Okay, finished? Right. Other than that, there are a few other remarks. Remarks in the sense, important points. Right? So we'll mention some remarks as well. Remarks or important points. Right? So as the last thing, we will mention these things, mention these points one by one. Right? So if you have any questions, ask me meanwhile. First point here, remarks. Drag the center weight downwards. Drag the center weight downwards. Drag the center weight. Drag the center weight downwards and release. Drag the center weight downwards and release, and check whether it comes back to its initial position, and check whether it comes back to its initial position. Right? If it comes back, there's no friction. If it comes back, there's no friction on pulleys. If it comes back, there's no friction on pulleys. Right? If it comes back, there's no friction on pulleys. If not, apply some lubricant oil. If not, apply some lubricant oil. If not, apply some lubricant oil to pulleys and reduce friction. Apply some lubricant oil to pulleys and reduce friction. Right? Second bullet, second point. If strings have a significant weight, if strings have a significant weight, it decreases the accuracy of experiment. 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 It decreases accuracy of experiment. Therefore, it is recommended to use thin light strings. 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 Right. Next point. Next point. At weights of pans. At weights of pans. At weights of pans. To known weights. To known weights. To increase accuracy. To increase accuracy. To increase accuracy. And have better results. To increase accuracy and have to increase accuracy and have better results. To increase accuracy and have better results. Okay. Okay. Again. Look at the board again. Now, vector parallelogram is verified. Right? Listen. Vector parallelogram is verified. Now, if this is verified, we can use the same setup to determine an unknown weight. Right? That is the next step of this experiment. Right? Look at the board. Now that is why we have this. Yeah. A small stone or a glass stopper. Small stone means that's an unknown weight. Small stone. Stone glass stopper as long as you can hang it from the string here, you can measure it. Right? So we'll take a small stone or a unknown glass stopper. Unknown means we don't know the weight, we haven't measured the weight using triple beam balance. Right? And then you are replacing this W2 with that unknown weight. Right? Look at here, look at the board. The last part, final part of the experiment, we are replacing this with the unknown weight. Let's say mg. We are replacing that with the unknown weight. And you can do the same again. And then again you will get another diagram. Let's say now in that case, this is OA dash and this becomes OB dash. You will get another parallelogram like this. Now tensions will be different. Huh? Why? Tensions are different because weights are different. Tensions are different. Which means lengths are different. Different and your parallelogram will be different. Right? Everything will be different. And then complete this again. Let's say C dash. Right? And now this is again a system in equilibrium. So therefore, if you measure the length from here, let's say R dash gives us the unknown weight. Equilibrium में क्या So likewise, unknown weight can be determined. Right? Very simple. Very simple. Now, if that is verified, determining an unknown weight is just one step away. Just one step away. Right? Okay. As the next thing, write down determination of an unknown weight. 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 Determination of an unknown weight using law of vector parallelogram. Using law of vector parallelogram. Using law of vector parallelogram. And one more thing, you have to follow the same scale when you draw the second parallelogram as well. The scale you have to follow the same scale. Right? I'll say here you got a length of 18 centimeters, then there is 18 newtons. likewise. Right? Okay. Write down below. Replace weight W2. Replace weight W2. Replace weight W2. Replace weight W2 with unknown weight. With unknown weight within brackets mg. With unknown weight within brackets mg. And repeat the experiment. And repeat the experiment. And repeat the experiment. And repeat the experiment. To construct. And repeat the experiment to construct. And repeat the experiment to construct O A dash C dash B dash parallelogram. O A dash C dash B dash. O A dash C dash B dash parallelogram. And measure diagonal OC dash. 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 Next point, using the same scale, determine the unknown weight. 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 Right. Okay. And take this down. This diagram, second parallelogram. Write down the second parallelogram. Okay, so that's the end of practical 1, experiment 1, right? Any questions before moving on to the next one? So will you repeat the last point? Very good. Yeah, it's good to see that you have you are sharing the note and everything among your friends. That's good. Right. What else? So, sir, the points you gave together is for both the parallelograms. You mean under method 1? You mean under method 1 under method 2 points? Remarks. That's overall. That's overall. Same thing. We are repeating the same. Same thing. We are repeating the same. Any other questions? Clear? Clear? Okay then. Okay. Right. So you can read what is given in the Tute later, right? So as I told you, that is just a summary of this is given there. That's just a summary, right? Refer this as the main note because here I have explained to you everything you need to know, even without missing anything, right? And in the last page, I have mentioned the past paper questions which has already come from these ones. So later on, you can try them. The last page, yeah. Parallelogram 2005 and 2022. Right? So after the session, you can try writing answers for those questions as well. Right? Hare? Next one. Right. Okay, let's go to the next one. Right. Practical 2. Next one. Practical 2. Okay, practical 2. Take down the heading as determination of mass of a body. Determination of mass of a body using principle of force moments. Body using principle of force moments. Force moments. Using principle of force moments. Right. Okay, first let's see the theory part involves here. Theory. Okay, listen. What is force moment as an equation? How are points A and B marked on the board? On the parallelogram? According to the scale. According to the scale. How? T1 is known. Ne? Since T1 is known, now let's say you have measured T1 using triple beam balance as 8 newtons. Right? If there is 8 newtons, according to the scale I have chosen, I have to draw a line of 8 centimeters long. Right? Then that end point is point A. So do we want to copy parallelogram A dash? Yeah, we copy down. Yeah, you copy down. Okay, listen. As an equation, first tell me what is the force moment? What is force moment as an equation? What is force moment as an equation? Basics. Force moment. Usually we say G. What is force moment as an equation? Huh? Quickly. So did you say to copy the practical setup? I guess I didn't get your question. You are asking whether the first one about the first diagram. Mathematic diagram. What is the force moment? Force moment is a force into perpendicular distance. Is defined as a force moment. Force moment is a force times perpendicular distance as an equation. Force times perpendicular distance. Right? So therefore, force moment is defined as F times D. Force moment. Right? What is principle of force moments? For a system in equilibrium. For a system in equilibrium. What is the principle of force moments? Now, with the previous example or previous experiment also, I had to explain. There are two conditions satisfied by a system in equilibrium. One is algebraic summation of forces along any direction is 0. And the other one is algebraic summation of force moments around any point is 0. Right? So therefore, if a system is in equilibrium, see, look at here. Look at here. Let's say these two weights are kept on this as let's say its weight is m1g and this weight is m2g. and this is a pivot point. Let's say G, and say this is D1 and this is D2, right? If the system is in equilibrium, look at here, there is the theory here. If the system is in equilibrium, force moment in counterclockwise direction about G equals clockwise force moment about G, right? Counterclockwise force moment is due to M1G. Force into perpendicular distance, so M1G times D1 equals clockwise force moment is due to M2G, right? M2G into perpendicular distance, then M2G times D2, right? So this is the principle. This is the principle. So therefore, if a system is in equilibrium, force moments are equal. Force moments are equal. That is why algebraic summation becomes 0. Algebraic summation means plus minus addition, right? So therefore, force moments are equal, right? Okay, this is the theory involved here. Take it down. This is the theory part involved here. Take it down. What's the full form of M1G? You're asking the meaning. I considered weight of pan as M1G. I mentioned it here somewhere. Weight of pan. Finished? Finished? Okay. Next thing. Okay, look at the board. First thing, we have to have a meter ruler and a knife edge for the experiment. I know you know meter rulers. What's a knife edge? Knife edge is there no? Knife edge means that is not actually a knife edge. Again, a knife edge. Knife edge means a very thin edge like this that we can keep something on it. This is called knife edge, right? It's like a needle. A needle knife edge. That is called knife edge, right? The reason to say that as a knife edge is because that's very thin. Knife edge edge tip thin, right? Hey, make a stand make lab make a stand knife edge on stand. This is a knife edge, right? We have to have a knife edge first and a meter ruler, right? And a meter ruler. Okay, look at the board. Look at the board. First thing is we have to take the meter ruler and we have to keep this meter ruler in equilibrium on the knife edge like this. You have to keep the meter ruler in equilibrium on the knife edge like this, right? Now, even though it's a symmetric meter ruler, its center of gravity is always not going to be at 50 centimeters, right? There can be differences that we don't know, so we can't rely on that, right? So therefore, we are taking the meter ruler and if we can balance it on the knife edge, the point where it balances exactly should be what? Should be the center of gravity. Now, otherwise, if there is not the center of gravity, it collapses, right? If there is at the center of gravity, right, it balances. Are there any sticks somewhere? මොනවා sticks තියෙනවද වෙනවද? දන්නවනේ ඒක කරන්න පුළුවන් කියලා දන්නවනේ. පොඩි කාලේ කොස්සෙම balance කරලා තියෙනවා. හරි ඒක දන්නවද? Is there anything that I can show you? No. So you can imagine, no? So likewise, on the knife edge, this meter ruler should be balanced, right? On the knife edge, this should be balanced. Now at that balance point, I mean, make a balance around. At that balance point, it is balancing means center of gravity is at the same point. Otherwise, if that is not at the same point, there will be a non-zero force moment. With that force moment, it collapses, right? If it is balanced, which means center of gravity is there, right? Now, doing this, first thing is you have to find the center of gravity of meter ruler. You have to find the center of gravity of meter ruler, right? Now, from center of gravity, what is center of gravity, by the way? What is center of gravity? So how will it be balanced in the knife edge? This is not a rocket science. Just keep it on the knife edge and change the position accordingly until it balances. Haven't you balanced booms like sticks in your childhood? මන්නම් කරලා තියෙනවා. මම ස්ටික් එකක් තිබ්බනම් පෙන්වන්න තිබුණාට ස්ටික් එකක් නැහැ පෙන්න. Yeah, that's it. Along with it. Can I throw it? Was it a pen? I thought it's a pencil. Oh, okay. Now assume this as a meter ruler. Assume this as a meter ruler. Then keep it on the knife edge. Once it is kept on the knife edge, if there is not balance, which means your center of gravity is not at the point of the knife edge. Like this, it falls. Once you take hands off, it falls. But if it balanced, see, it can be kept balanced like this. You have to find this position. Now, which means center of gravity of this pen is here. Right? Center of gravity of this pen is here. Right? Make a rotate pen now. Make a pen එකක් ඉඳලා. Center of gravity is here. That's the same idea. Center of gravity of the meter ruler is now at that same point. Is it broken? Won't it fall then? But the knife edge is very sharp, then will it fall? No, it won't fall. Now that's the beauty of physics. It won't fall. When you take that knife edge exactly to this point, because center of gravity is a point. It's a point. Right? Make a balance කරන්න පුළුවන් එක needle එකකින්. Right? පස්සේ කරලා බලන්න එක needle එකෙන් balance කරන්න පුළුවන්. Right? හරියටම මේ point එකට එනවා. Got it? Okay. So what I asked about is what center of gravity? What is center of gravity? We have discussed in the theory class like how many months back? 5 or 6 maybe. More than 6, I guess. Yeah. What is center of gravity? The point where weight, yeah, good. The point where weight of an object acts. Right? Acting point of weight. Center of gravity is acting point of weight. So which means weight of this meter ruler acts here. Right? That's why it is in balance. Right? Otherwise, if there is not in balance, what happened is, let's say center of gravity somewhere here. Now this creates mg. This creates a force moment of mgd, and this falls in this direction, right? When this point is taken to here, since there is no perpendicular distance between that point and the knife edge, no force moment, zero force moment, which means it won't fall, right? That's the thing. Okay, listen now. Listen. Okay, now this is balanced. Now this is balanced. And then we have to have two weights. So, materials clear. Now, list down. Now we have a meter ruler. What else? A knife edge. A knife edge. Other than that, we have to have two weights. One is a known weight and the other one is an unknown weight. Determination of a mass. To determine, we have to have an unknown one. Otherwise, if it's known, there is no point of determining. No. So therefore, one known weight or one known mass and one unknown mass. One known mass and one unknown mass. Right? Okay, look at here. Now, using strings, using thin strings, we have to, listen, we have to hang the weights here on the meter ruler. You have to hang these weights on the meter ruler. Right? Let's say my known weight is capital M. My known weight is capital M. So here that it has a weight of mg. Right? And now as this equilibrium is not broken, you have to fold the other weight, the unknown weight, on the other side like this. So this is my unknown weight. Simple M. Simple mg. Right? And the purpose of using a meter ruler is to take readings easily. Now in meter ruler we can see the scale. We can see the scale. Now this is not exactly at 50 usually. It will be around 50. Right? Make a 75 volt again. Meter rulers. Meter ruler is just uniform. But we don't know whether it's exactly uniform. Make exact 50 volt. It may be like 51 sometimes, 49 sometimes. Somewhere around. Right? But somehow we know the scale and the point there on the meter ruler. Let's say that is 51.1, then we know that as 51.1 centimeters. So therefore, these lengths can be read out at once using the meter ruler itself, right? So let's assume this distance from here to here as x, this distance from here to here as y, right? Now if this is balanced, the idea again is this. If the system is in equilibrium, if it is balanced, these two force moments should be equal, and there is no force moment comes from mg of meter ruler, since I have balanced it to the knife edge. We are going to write the force moments about knife edge, right? No perpendicular distance to the weight of meter ruler, since there is acting through the knife edge, right? Therefore, now if I consider equilibrium, see, look at the board, don't write. By considering equilibrium, force moments about G in both directions should be equal. Counterclockwise force moment equals clockwise force moment. Counterclockwise force moment is due to this one, capital Mg times x, and clockwise force moment is due to simple mg times y. Right? Now you can see G to G cancels, right? What comes is mx equals my, capital Mx equals simple my, right? Okay, now from here we can read two readings for x and y. No? You can read out from the scale, 51 x is 51, let's say this is at 20, this is 31, something like that. You can directly read it out, right? You can read these readings. So likewise, what we are doing is this. We are, look at the board. We can do the same for around 6 readings. Now there's a practice like we need minimum 6 readings to draw a graph simply. Graph after minimum 6 readings here. That's a practice. That's the practice we practice in A levels. Right? Minimum 6 or more than that. Graph because the accuracy is very low. So therefore, minimum, when we take readings in something, we are taking 6 readings. Keep that in mind. To plot a graph, if you are taking readings, minimum number of readings you have to take is 6. Minimum is 6. Right? Now, likewise, now we are going to change x. Listen, we are going to change x. Distance of the known weight is going to be changed. We are going to change x. We have hung this from this point. So we are taking this to this side a little bit. Then accordingly, this should also be moved away to counterbalance again. So likewise, we have to do it 6 times for 6 instances. Right? And then you can get 6 pairs of x and y onto a table. 6 pairs of x and y onto a table. Right? And now we were changing x. In a graph, changing variable is called the which variable? There are 2 variables for a graph. What are them? What are them? X and y. What are the names? What are the names of variables x and y? No. Independent variables and dependent variables. Independent and dependent. X is called independent. Y is called dependent variable because y depends on x. Right? So independent variable means a changing variable. Independent means that doesn't depend on anyone. But y is depending on x. Y is called dependent variable. Now we are changing x now. Changing variable is the independent variable. Now independent variable will be x, and with respect to x, y changes accordingly. So therefore y becomes the dependent variable. That's why I use x and y for you to see it properly. Right? L1, L2 right? X is the changing variable, independent variable. Now, since we need to plot a graph, we can make this equation to plot a graph. See, now my dependent variable is going to be y, subject y from this. See, y is given by capital M over simple m x. Y is given by capital M over simple m x. Right? Now, if we plot a graph using this, now my y axis is as same y, x axis is same x, and this part will be the gradient. Anything which is as a product with x is a gradient. Right? You can see, right? So we will get a graph of the shape y equals mx. We will get a graph of a shape y equals mx. Right? So after taking these 6 readings, what we do is you are plotting this graph. You are plotting this graph. Right? On a graph sheet, on a graphing sheet, we are plotting this graph y and x. Right? Then you can mark these points. Now you have 6 points. You are marking these points and plotting the graph. Always not all 6 points are going to come onto the same straight line. That happens when we do experiments. Right? So majority graph and gradient of this graph is gradient of this graph is gradient. Let's say k, gradient k. Usually we use simple m for gradients. Since we have a simple m already here, I'll be using k for this gradient. This gradient is capital M O simple m. That is what is coming from here. This gradient is capital M O simple m. Right? Okay. Let's see what we are going to do with the gradient now. Now we have finished the note here. Materials with there. Okay, as a next heading, write down materials and apparatus. Next heading, materials and apparatus. Next heading, don't write anything here. Don't write anything here. Write the heading, materials and apparatus. Materials and apparatus. Right? Okay. First write down materials. First materials. Under that, first thing materials. First thing material. Right. Write down one by one. Meter ruler. A meter ruler. A meter ruler. A meter ruler. Second one, a knife edge. Next one known weight. One known mass. 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 Within brackets. Within brackets. 50 grams. Within brackets 50 grams. Next one unknown mass. One unknown mass. One unknown mass within brackets. A small stone. A small stone. Stone. unknown mass එකට ගන්න මොකුත් නැත්නම් අපි හැම වෙලාවෙම ලැබ් එකේදී ගන්න එක්කෝ ගල් කැටයක් එහෙම නැත්නම් අර glass topper එකක්. right? ඒක තමයි small stone or glass topper. Glass topper එක use කරන්නත් පුළුවන්. right? Next one, a piece of string. A piece of string. මේ දෙක එල්ලන්න strings ඕනේ. A piece of string. A piece of string. Last one, a wooden block. A wooden block. A wooden block. A wooden block. Okay, look at here. If this height is not enough, you can use a wooden block here and take it to a required height. That's why a wooden block is the wooden block. Wooden block. Right. Okay, next heading apparatus. Next heading apparatus. Next heading apparatus. So it's a ruler you have drawn. So it's a ruler you have drawn above the neck. Yeah. This is a meter ruler. This is the meter ruler. This is the meter ruler. Dependent, that's good. So can't it be mx of m instead of, you're asking gradient. Gradient is always the part which is as a product with x. Now let's say you have an equation like, see, y equals 2x plus 5. Y equals 2x plus 5. 2 is the gradient. Right? 2 is the gradient. The multiplier, the coefficient of x, coefficient of independent variable is called the gradient. Because gradient is y of x. Gradient is tan theta over y of x. That is how gradient is defined. And now, for the experiments coming up, graphing knowledge is needed because for all other experiments, we are going to use graphs and get something done using the graphs. If you don't know about graph plotting, I have conducted a class like 5-6 months back about graph plotting for LBS physics. Right? That video is still available on my YouTube channel. So you can just go there. I think it's around 3 hours long, maybe 2.5 hours, 3 hour long video. Right? You can go there and check everything out. There are 16 different types of standard curves we have. Right? All 16 curves we have to know. And about gradients, gradient types, graph plotting, and it was ended with the discussion of 20 or 25 graphing questions. I think 20, right? 20 graphing questions. That Tute is also you can get. Now, I think I have pinned that in the, not pinned, I have mentioned that in the description of the video. Just go to the description of the video and click on a link. I guess the link is there. Go to the link and you can download that Tute as well. I gave a small Tute for that thing. So please watch it in a leisure time as early as possible, because now you are in a high time to know about graph plotting for all experiments. Most of the experiments, graphing is coming, and other than that, when it comes to 50 MCQs, there are 10 graphs. There are 10 graphs in 50 MCQs, right? And in structured essays, you are getting graphs. Essays also you are getting graphs. around 15% of marks out of 100, final 100 marks, around 15% is allocated only for graphs in A-level physics, right? So therefore, knowing graphing is a must, right? Right? So if you are not familiar about these terms, graphing, gradients, independent variables, dependent variables, intercepts, y-intercepts, x-intercepts, and standard curves, right? In a leisure time, please go there and watch it. It says graph plotting for GC level physics. එම කියලා වීඩියෝ එකක් ඇති යන්නේ වීඩියෝ එක බලන්න. What should we need to do under the heading apparatus? Wait, I didn't say anything. I'm just looking at the questions. So sir, if I keep a ruler on the edge of a knife from kitchen, then ruler will be balanced from kitchen. Okay. From kitchen now again. Actual knife edge. Yeah, it will be balanced. Listen. Listen. It will be balanced. It will be balanced. Now, if you do so, listen, if you do so, now, you know, if this is a meter ruler, there are two symmetric axes going like this. So the exact point is coming to the center point, middle point like this. So first find that center of the meter ruler and keep your knife at that center point. Then it will be balanced, right? Otherwise, now in this knife edge that is in the lab, there's a small modification done to make it easier. The knife edge is like this. It's having a small width. Even though it's thin, in these knife edges we have in labs, it has a small thickness like this. So meter ruler එකක් වගේ තිබ්බට පස්සේ meter ruler එක මේ ගානට මේකට හිටිනවා. ෆෝන් එක වැටුනොත් මෙන්න මෙහෙම meter ruler එක ගානට තියන්න පුළුවන්. In that case. ඒක dot එකක් නෙමෙයි, ඒ කියන්නේ ඒක needle එකක් වගේ dot එකක් නෙමෙයි. It's very sharp. But like this it has some kind of a thickness. පොඩි thickness එකක් තියෙනවා. උතර ගානට thickness side එක උඩ මෙහෙම ගිහිල්ලා තියන්න පුළුවන්. ඒක ලේසි. නැත්තම් මෙහෙම දැන් මේ edge එක උඩ තිබ්බම දෙපැත්තටම මේක imbalance වෙනවනේ. මේක වගේ උඩ තිබ්බට පස්සේ ඔයාලට මේ direction එක විතරයි බලන්න තියෙන්නේ. right? මේක උඩ balance කරන්න පුළුවන් ඉතින් මොකක් හරි තිබ්බනම්. And this should be firm on the table, because naturally we have our own vibrations. Human hands නෙමෙයි body එකම natural vibration එකක් තියෙනවා. ඒතර මේක මෙහෙම firm තියෙන්න ඕනේ. ඉතින් මට තියාගන්න බැරි. මේක firm තියෙනවා. මේක solid මේක තියෙන මේ table එකක් උඩ. This is on the table. So that is firm. That is fixed. Right? So ඒක උඩ ඔයා මෙහෙම ගිහලා මේක තිබ්බනම් ඒක ගන්න balance වෙනවා. Right? මේක හොල්ලන්න නැතුව තියාගෙන පුළුවන් කෙනෙක් ඉන්නවා නම් මම තියලා වෙන්න. මෙන්න මෙහෙම තමයි එන්නේ. නේ ටේබල් එක උඩින් තිබ්බොත් මම පෙන්නන්නම්. අත අපේ natural vibration එකත් එක්ක කරන්න බෑ. Naturally we have a vibration in our hands. Right? එහෙම තියන්න පුළුවන්. මේකට පොඩි thickness එකක් තියෙනවා. Then that would be easy. Don't write anything. I'm just answering your questions. So why are we taking an unknown mass for experiments? That is the experiment. See the topic? Now we are going to determine this using force moments. The experiment එක කළා මොකක් හරි හොයාගන්න එකක් තියෙන්න බෑ. Because experiments are done to get something out. Or to conclude something, to get something out. Right? Experiment එකක් කළා මොකක් හරි දෙයක් outcome එකක් තියෙනවා. Now the outcome here is we are going to determine this mass. So how many marks for MCQ paper? 50. 50. So will this recording be uploaded to YouTube? I missed the first few hours. Yeah, it will be there for today for sure, right? yeah, it will be on YouTube for today for sure. And yeah, I'll think whether it's to be kept on YouTube or gonna remove. Let's see with your behavior. Right, if your behavior is good, I can keep it on the YouTube. Yeah, for sure, for today, it will be there. Right, for today and tomorrow, let's say, it will be there. So what if it's given that the mass of unknown mass is approximately 60 grams and asked to choose the appropriate known weights out 50? That I didn't explain yet. Now, when you choose these masses, these two should be approximately equal. Otherwise, you won't get balance points. Right? Now, if you are using 50 grams, I told you the known mass is 50 grams. Usually, we are taking a 50 gram mass. If that is 50, now if you are using like 1 kilo or something on the other side, it won't be balanced. 1 kilo right? So it should be approximately equal. Now, for your question, the answer is 60. Whole paper marks 100. So can we buy a graph book for physics? You have to. You have to. Now, if you are not a private candidate, you are going to school then. There is one slot per week allocated for practical sessions. So weekly, there's one session. One session of 2 periods. 2. Oh. Right? So weekly, 1 hour and 40 minutes are allocated for practicals. Then you will be spending that time, that whole time in the lab. That is how these 42 practicals are going to be covered in the school weekly. That is how it's covered in weekly basis. Right? It will be covered weekly. Right? That's the idea. For that, you have to have a graphing book. Right? Now, usually for the practical period, experiments period, you have to have a graphing book. Right? That's all. Okay, right. So what do we write? Apparatus. Okay. First, write this down. Look at here. Look at here. First, take this down. Just the meter ruler on knife edge. Just the meter ruler on knife edge. Take this down. Take this down. Just the meter ruler on knife edge is balanced. Take this down. Only the diagram at left side. The structure they say marks are divided. Our second paper marks will be divided by 4. So one structure they say it carries 20 marks. So which means out of 100 there is 5 marks. Right? One structure essay is for 20 marks. So making structured essay का आपको 20 marks. Out of 100 there is 5 marks. Right? You have 4 structured essays, which means 80 altogether. When taken down to 100, that is 20. Right? Structured essays are 20%. That's a huge amount. 20% out of 100. 1/5. 20%, that's a huge amount. Right? 20% කියන්නේ 20 marks. 100 එකක් කෙලින් මේ එකක් වෙන මාක් එකක් නේ. 55 එක 75 එක ගන්න නේ. Very critical, very critical. We'll be getting 4 experiments from all 39 available. Right? 4 out of 39. It's for 20 marks out of 100, final 100. That's all. Okay. Write down below. Write down below. Keep the meter ruler. Keep the meter ruler in equilibrium. Keep the meter ruler in equilibrium. Keep the meter ruler in equilibrium on a knife edge. Keep the meter ruler in equilibrium on a knife edge. Keep the meter ruler in equilibrium Keep the mean ruler in equilibrium on a knife edge. And find its center of gravity. And find its center of gravity. And find center of gravity. And second point, hang the known mass and unknown mass, hang the known mass and unknown mass hang the known mass and unknown mass in either sides of meter ruler using strings. In either sides of meter ruler using strings. In either sides of meter ruler using strings. Right? Take this down. Only the diagram. Don't write this thing. This thing comes under method. Now we are still in the apparatus. Take down this diagram. Only the diagram. Only the diagram. Up to here. Take down only the diagram. Nothing here. Not the table. Not the graph. No. Just the diagram. Take it down quickly. So if you have any questions, you can put them into the chat, right? I can see all your chat now. When I check your chat, I can see all your messages. That's why I'm answering all of them at once, right? Otherwise, it's not practical to check them one by one, right? So I'll discuss this with the flow, and then once I check the chat boxes, I can answer all your questions at once. Finished. Use different colors if needed. That's up to you. That's up to you. Right? Okay. Then next heading, method. Next heading, method. Next heading, method. Record 6 readings. Record 6 readings. What? Which door? Second floor. Yeah. Don't close kill again. Hare. What did I say? Record 6 readings for X and Y. Record 6 readings for X and Y by changing. Record 6 readings for X and Y. Record 6 readings for X and Y. Record 6 readings for X and Y by changing the distance from, by changing the distance from, . balance point to non-mass by changing distance from balanced point to non-mass by changing distance from balanced point to non-mass by changing distance from balanced point to non-mass. Within brackets x, within brackets x. Okay, then write this down by considering equilibrium and write down up to here. Up to here, by considering equilibrium. By considering equilibrium, write this down. And now we have got this equation y equals mx. Y equals mx. Now that is in the shape of y equals mx. That is in the shape of y equals mx. So is the previous 2 points you gave should be write in red? No. Finished. Okay, now take this down, this table. Here we have 6 pairs of values. 6 pairs of values. Right? This is called data table. Data table. Data table. Right? Okay. Then we are going to plot the graph. Look at here. According to above equation, get here. According to above equation, now we know final equation is y equals capital M over simple M times x. Right? So this is in the form of y equals mx. This is a standard curve. Y equals mx is a standard curve. This is in the form of y equals mx. Right? So standard y equals mx curve is this. Standard y equals mx curve is this. Right. Standard y equals mx curve is this. Right. Now, using this, gradient, let's say k equals capital M over simple M. Right. Since k equals capital M over simple M, see k equals capital M over simple M. The unknown weight is this one. This one is the unknown one. Right? Known is capital M, unknown is simple M. Right? Then simple M is given by capital M over gradient. Simple M is given by capital M over gradient. If gradient is known, capital M is a known weight anyway, known. This is known. If gradient is known, simple M can be determined. Right? Now, once the graph is plot, what we do is you can select any 2 points and get the gradient of this graph using delta y or delta x, which means gradient is known because k equals, I'll mention here. Now k from the graph, k is a gradient. Gradient equals y over x or delta y over delta x, change of y over change of x, delta y over delta x, which means is known. If that is known, plug that value here, simplify, we can find simple as that. It was determination of mass, right? So mass is determined, right? Now, just by taking one pair of readings also we can find simple length. Right? Listen. Just by using one pair of x and y also we can find simple length. May first equation එක ලියපු ගමන් x and y දන්නවනේ. Can find, but we don't do it. The reason is accuracy is very low. When we have multiple readings, 6 readings, accuracy is good. So that's why we are going to a graphing method. Always in graphing methods, accuracy is higher. Gradient එකකින් ඇවිල්ලා තියෙන්නේ. නැත්නම් එකපාරට මේ equation එකට දාලා ගන්න පුළුවන්. නැත්නම් accuracy එක නැහැ. එහෙනම් එහෙම කරන්නේ නැහැ. Right? එහෙම කරන්නේ නැහැ. We don't do it. Right? Because now this is A-level physics. You have to do experiments with an accuracy. නිකම් මේ toys එක සෙල්ලම් කරනවා වගේ නෙමෙයි මේක. ඇත්ත දෙයක් නෙමෙයි කරන්නේ. Right? So that's why we are going to the graphing method. නැත්නම් මේ equation එකට මෙතෙන්ට ආපු ගමන් x and y and capital M unknown. If you simplify the equation, you will get simple M. But that is not that accurate. That's the reason. Always we are going to the graphing method. Right? Okay. Now start from here and write up to this point. Start from here and write up to here. Yeah, that's it for this second experiment as well. There are a few important facts to be mentioned. As the previous one, I'll mention few facts as remarks and important points. Right? Other than that, now the method is this. That's done. That's it. Any questions? So what's that last formula? Y equals mx. Y equals mx. This one here. Y equals mx. This is a standard curve. Y equals mx is a standard curve. You have y equals ax squared plus bx plus c. Standard curves. Right? Y equals mx plus c. Standard curves. So they are standard curves. So there's no time to wait if you don't know graph plotting. Right? I'm serious. From my side, the only option that I can give you is that recorded video of the class is on YouTube. So you can watch it later. Right? Allocate some time and watch that video and practice those questions. There are 20 questions. We practiced after the session. Right? That is also in that session, that's in the video. So you can watch it and make yourself comfortable with graph plotting, because that's a must needed skill. Otherwise, without knowing graph plotting, don't go to the exam. Right? 15 marks or graph plotting dannadu exam එක යනවා කියන්නේ 100 වලින් නෙමෙයි වට marks එන්නේ 85 වලින්. Right? 15 will be for graphs. So do you want to copy the data table after graph or copy? I told you to copy it down. I asked you to copy it down. Data table copy කරන්න කිව්වේ නේද? I asked you. නේද? I asked you to copy down the data table after this point. Didn't I? No? Huh? Yeah, I said. I said. I asked you to copy down the data table after this. Without the graph. Graph එක නැතුව data table copy කරන්න. If you didn't copy it somewhere around. Right? That is when I label this as data table. Right? Copy it down somewhere around. That's fine. That's fine. ඒක critical එකක් නෙමෙයි ඉතින්. ඒක copy කරලා තියාගන්න. If you have put direct messages to my personal account, please forward them to the Machma account, because I'm watching at the chat there. That's why. YouTube chat is on my other laptop. That's why. Right? Finished? Okay. Last heading, remarks / important points. Remarks / important points. Remarks / important points. Remarks / important points. Okay. Write down in point form as bullets as we did before. Right? First point. Weight of meter ruler. Weight of meter ruler has no impact on force moments. Has no impact on force moments. Weight of meter ruler has no impact. Has no impact on force moments. Has no impact on force moments. Since its pivot point is at center of gravity. Since its pivot point is at center of gravity. Since its pivot point is at center of gravity. Since its pivot point is at center of gravity. Pivot point is at center of gravity. Next one. Using two approximate weights. Using two approximately equal 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 weights. Gives a good spread. Gives a good spread. Gives a good spread. Gives a good spread for readings of x and y. For readings of x and y. Good spread. Good spread කියලා කියන්නේ listen. Good spread කියලා කියන්නේ match වෙන්නේ නැති values ගත්තොත් එහෙම මේ graph sheet එකේ වාගේ graph එක පොඩ්ඩියට එන්නේ නිකන් මෙහෙම එනවා. වැඩක් නැහැ spread යන්නේ. Right? Then in such cases percentage errors are high because always higher lower reading percentage errors are higher. Percentage error දන්නවනේ percentage error is least count over reading. Right? Always lesser the reading higher the percentage error. So therefore we have to have a good spread. මුළු sheet එකම use කරලා ඉතින් මේක ලස්සනට අදින්න ඕනේ. Right? එහෙම වෙන්න හොඳ spread එකක් තියෙනවා. Okay, what did I say? Equal to versus gives a good spread for the graph. Is it? Readings of x and y. What did I say? Using two approximately equal weights gives a good spread for readings of x and y when plotting the graph. When plotting the graph. When plotting the graph. Next point. Accuracy of the method is higher since it's a graphing method. Next point. Accuracy of the method of this method. Accuracy of this method is higher since it's a graphing method. Accuracy of this method is higher since it's a graphing method. That's what I mentioned before. Now, even though we have an equation here, we don't go for the equation. That is less accurate. Right? Always we have to go with the graph. පොඩි කාලේ වගේ ඩොග් ගාලා ඉක්වේෂන් එකට දාලා ගන්න නෑවද? එහෙම තමයි ඇටි. Now you are A level physics students no? Physics. Right? නැත්නම් නිකම් මේ ඉක්වේෂන් එකට සබ්ස්ටිටියුට් කරලා එහෙම ගන්න නෑ. Got it? Got it? Okay. Right. That's all. That's all. So that's the end of practical 2. Right? That's the end of practical 2. So before giving the break, I'm planning to finish first 3. Otherwise, we will be running out of time. Okay, now it's 11:39. We have around 1 hour. All right. Any questions before moving on to the third one? Any questions before moving on to the third one? So I had written in red, is it mass? What is capital M? What is capital M? Non-mass. Non-mass. Someone had answered. Ne? Good, very good. No, it's known. Capital M is known mass, simple M is unknown mass. It's see there. Known mass is capital M. Unknown mass is simple M. Last point. Accuracy of this method is higher since it's a graphing method. Accuracy of this method is higher since it's a graphing method. Okay, that's it. Any other questions before moving on? Before erasing? What about you? All clear? The ones on YouTube? What about you? Now, when I ask something that's for both of you, doesn't matter if you are on Zoom or YouTube, right? If you are online, you can put your things, put your doubts, questions, anything to chat box. Or is it clear? So at least put the thumbs up if that is clear enough. Otherwise, I'm going to erase this. We are going to move on to the next practical. All right, good. Okay. Okay, right. Okay, what about the first 2 practicals so far? Now we started this session around 8:45 or something, 8:45 or something, and now it's 11:42. 11:42. Yeah. What about the 2 experiments we discussed? I mean, how do you feel? I couldn't hear. So what is capital M in gradient? Capital M is non-mass. Wherever it is, that is non-mass. What do you say? Clear? Right. So you have spent your holiday effectively and productively so far, right? No, otherwise, if you don't have school, what do you usually do? You don't have any. If you don't have school, what do you do usually? Sleeping until 10, 11, is it? Online students? Online means you are anyway the lazy ones. That's why you are joining online. I mean, if you are around Colombo, if you are from a remote city, that is fine. That is totally fine. But I can see there are some students who live around Colombo also in the online class. That is because of the laziness you have, right? That's the laziness. Yeah, tell me. Yeah, you are sleeping, eh? If you don't have school on a regular day, usually what you are doing is you are sleeping, right? Give me a minute. No, maybe around 2 or 2:30. Dude. Right. I think you have a space to sit there. All right. So that's so effective. We are saving the time for transportation, taking for transportation. Very good. I said if you are around Colombo in the sense if it's like let's say 30 minutes, 45 minutes, that will be just that's not a waste. That's not a waste. That's just a productive time you are spending, right? And I know there are some students who live like very close by, like 30 minutes away. In the online meeting, that's why I told you. So what is capital M in gradient in red color you wrote? Known. මේක දැහුවේ එච්චරලා. Known. And gradient is also known from here, which means M can be determined. Now, if needed, put a point somewhere here. Since capital M and K are known values, simple M can be determined. Right? Or number point at that. Since capital M and K are known values, somewhere here. Since capital M and K are known values, simple M can be determined. Since capital M and K are known values, simple M can be determined. But we are better than physical because they are sacrificing time, but we are sacrificing ice. Yeah. Now, yeah, that's totally up to you. Again, up to you. There are some students who are not familiar with the online things, but there are some of you, they are very much familiar with the online setup. So that's why nowadays in the modern setup, we have to go with both. Right now, actually before COVID, we didn't have any online thing. Right? Everything was physical. But now after the COVID, now even though that's a disaster came, there are some positive sides from that as well. So one of the things is this, right? Now otherwise, now the access to these kind of classes for any student is, it was not there. And if there was no, I mean, if there was nothing happened like COVID, I don't think we will do this conversion, this evolution this much faster. Now, for COVID, we have to stay around like 1 to 2 years, I guess, 1 to 1.5 years or something, as working from home, inside home. And in those days, we had to shift by, I mean, by whether you like it or not, right? By hook or hook, we had to shift to it, right? For companies also, all the meetings were taken online, all classes were taken online, and we got used to that culture, right? So that's one of the good things actually, right? So what I'm saying is online learning is a good thing. Online learning is a good thing, right? Any student anywhere in the world can access any class, right? That's the beauty. That's a good thing. That's a good thing, right? I clearly said I said for the students who are around, right? Candy නංවා candy නම් මෙහෙන්න එපා ඔබේ. Candy නම් මෙහෙන්න එපා. And It may be I'm the one who is coming from the furthest point to the class. It takes around 2 hours for me to come, right? So my today's schedule is yesterday it was around 1:30, 1:45 in the morning. In the morning means in the dawn when I'm going to sleep. So I had to finalize several things about this today's seminar, and then had to wake up at 5, right? And then I got ready and came. It usually takes around 2 hours to come here from Corona, right? And I was here by 7:30 anyway. One thing is I forgot that today is a mercantile holiday, so there was no traffic. Then I came faster. Otherwise, the areas like Vallavatta, this corridor is having heavy traffic in these office hours now. So I actually forgot that that's a mercantile holiday. I knew that that's a public holiday, but I didn't know that it's a mercantile. Then I checked, since I noticed that there's less traffic on roads, I check whether it's mercantile. Then only I noticed that it's mercantile. So therefore there was no traffic. So today I came, yeah, in around like 1.5 hours. So I was here by 7:30. Can anyone send a pic of the note? Oh, yeah. You have got it? Okay. Right, good. Let's move on. Practical 3. Practical 3. Practical 3. Take down the heading as determination of relative density determination of relative density determination of relative density determination of relative density of a liquid determination of relative density of a liquid using U-tube. Determination of relative density of a liquid using U-tube. Practical number 3. Of a liquid using U-tube. Right. Okay, you know U-tubes, right? What's the U-tube you know? Huh? What's the U-tube you know? Okay. No questions? Right. Okay, look at here. Determination of relative density using U-tube. First, the theory part is this. Now, this is an experiment which comes in hydrostatics. The theory part comes in hydrostatics. Right? Hydrostatics. U-tubes. See, this is a theory. Look at the board. Don't write, just look at the board. These are U-tube. Say two different liquids are put onto the U-tube here. Two different liquids are put onto the U-tube here. This is one of the liquids, right? And this is the other liquid here. right? The point where, or the interface where the two liquids meet each other, this point is called the interface. That is called interface, right? The level where two liquids meet each other is the interface. That is called the interface, right? And this is open to surroundings from top. So it has P naught. Let's assume P naught as atmospheric pressure. Atmospheric pressure. If there's any surface which is open to atmosphere, it has atmospheric pressure. If there's any surface, now if we take our body, how many points are open to atmosphere? 10? Sorry? No. What are 3 points? How many points of our body are open to atmosphere? Yeah, what are 3 points namely? Points, I'm asking about points. How many points? Infinite number of points are there, right? So there are infinite number of points which are open to atmosphere. Each and every point on this body feels atmospheric pressure, right? That's why we feel nothing, because from everywhere that pressure is same. Otherwise, if the pressure is higher in one side, you will feel a pain there, right? Right? Now, even though atmospheric pressure is a very high pressure, as a value, atmospheric pressure is this much of pascals. It's a high value, right? Even though it's a very high value, we feel nothing because each and every point of our body is on the atmosphere, right? Then from all sides, that same pressure acts. Resultant cancels. That's the reason. මේ වගේ ප්‍රෙෂර් එකක් එක තැනකට වගේ ඇප්ලයි කරොත් මේවා කැඩිලා යනවා. මේ ලොකු ප්‍රෙෂර් එකක් මේ. ලොකු ප්‍රෙෂර් එකක් මේ තියෙන්නේ. Right? Okay, now these two limbs are open to atmosphere. So it has atmospheric pressure there. Atmospheric pressure. Right? Now, let's say the height from here to here is H1 and density of this liquid is ρ1, and height of this liquid from here to interface is H2 and density of this liquid is ρ2, right? So we know pressure difference due to a liquid column can be written as H rho g. Pressure difference due to a liquid column can be written as H rho g, right? In hydrostatics, we know pressures at same points, same levels, same levels are equal. Let's say A and B. Now from hydrostatics, PA equals PB. Pressure at a same point of a liquid, of the same liquid, is equal. Pressure at the same level of a same liquid, same horizontal level of a same liquid is equal, right? So therefore, PA equals PB. Pressure at A can be written as, now starting from here we have atmospheric pressure plus going down, when moving down plus H rho g, moving upwards minus H rho g, moving down plus H1 ρ1 g, plus H1 ρ1 g equals PB from the other side, P naught plus H2 ρ2 g, right? Now if you simplify this, P naught to P naught cancels, G to G cancels, H1 ρ1 equals H2 ρ2. So this is the theory which is relevant to this point, relevant to this experiment, right? Using this theory, we are going to do this thing. We are going to determine a relative density, right? Next we'll see what a relative density is, right? We have discussed. We'll see what a relative density is. So before that, this is the first theory part we need to understand. If you have an interface is at the same horizontal level, pressures at the interface are equal if that's the same liquid. May same liquid at A also, this black liquid is in contact, at B also the same liquid. Otherwise, if there are two different liquids, it's not the case, right? It should be the same point. That's why we consider the interface. We can't consider somewhere here, because then it's not the same liquid, right? Therefore, it's a must to consider an interface, right? Okay, take it down. Theory. Sorry, before taking down, write this point under theory, write this point in red. Write this point in red. Write this point in red. Pressures at same horizontal level. Pressures at pressures at pressures at pressures at same horizontal level. Pressures at same horizontal level. Pressures at same horizontal level of a same liquid. Of a same liquid. Same horizontal level of a same liquid. Are equal. Are equal. What is P naught? P naught can atmospheric pressure. P naught. Atmospheric pressure. Right, now take this down. Take this down. Take this down. The theory behind this experiment. The theory related to the experiment. Take it down. There is one more thing to add here. Tell me, what is the relative density? What is the relative density? What is relative density? What is relative density that you learn in hydrostatics? I need a quick response. Relative density. Relative. What is relative density? Yeah. Density relative to atmosphere. No. Okay. Yeah, I got correct answers from few of them. Yeah, correct. Relative density is the ratio between density of an object to density of water. Relative density means density of any substance, actually. Object can a substance. Density of substance over density of water. This ratio is called relative density. Density of water. This ratio is called relative density. Right? Relative density is a ratio. Relative density is a ratio. Relative density is a ratio. Right? This is the ratio. That is called relative density. Right? What's the value of relative density of water? What is the value of relative density of water? Now you have the equation. 1. Yeah, it's 1. Relative density of water is 1 because relative density is density of a substance over density of water. If I need relative density of water, which means density of water over density of water, 1. Right? Yeah, that's the idea. That's the idea. Okay, good. So this is the theory part involves here. Take it down. Take it down. This is the theory part involves here. Okay. Questions? So what's that formula you have written at the top inside? Delta V equals H rho G. Pressure difference of a liquid column is H rho G. Are you from 27 batch? Are you from 27? Yes, that's why. Right? Otherwise, if you are from 26, right? If you are from 26, now you should be in waves, right? Mono class එකට ගියත් දැන් waves වල තමයි ඉන්න ඕනේ. ඒතර මේවා ඔක්කොම complete කරපු parts. That's why I asked. If you are 27, that is totally fine. Right? 26 කවුරු හරි ඉන්නවා නම් ඒ equation එක දන්නේ නැති. ඒක හරියන්නේ නැහැ. Because that is something covered in hydrostatics. Right? Okay. Okay, let's move on. Okay, this is the respective theory part. Okay. Look at here. This is the respective theory part. Okay, now look at here. Okay, first thing is, now we have to have a YouTube. Right? We have to have a YouTube. Okay, now this is the YouTube. Look at the board, don't write. Don't write, just look at the board. This is the YouTube. Right? And if we are finding a relative density, or if we determine the density of a liquid using a YouTube, we can't use two miscible liquids. Right? We have to use two immiscible liquids, because if these two liquids are mixing each other, you don't see an interface. Right? So it's a must to use two immiscible liquids. That's very important. Nah? Only for two immiscible liquids. Only for two immiscible. Only for two immiscible liquids. This is only for two immiscible liquids. Right? Like water and coconut oil. Water and coconut oil, they are not mixing. Right? Now, you can't use water with pure water with salt water. They mix each other. Right? Water with what we call what the අනිත් එක petrol නෙමෙයි petrol වගේ දාගත්තේ ඒකත් හරි kerosene, right? Kerosene use කරන පුළුවන්. That is not mixing with water, right? If there is not mixing only, you can use it in a YouTube. Otherwise, no point of putting or including two liquids into a YouTube if they are mixing each other. You don't see an interface, right? Listen, few important facts. Okay, now about the materials. Now, one thing is we need a YouTube. First thing you need a YouTube. First thing you need a YouTube. Right? And we need two immiscible liquids. And when we insert liquids into YouTube, we have to make sure that the liquid with higher density is inserted first. There's a pure logic, a solid logic behind that. The logic is this. Listen, the logic is this. If you include the density with lesser liquid first, once the density with higher liquid is put onto the YouTube, the liquid with lesser density spreads to both limbs of the YouTube. යා දන්නේ මොන පැත්තට දෙන්න ඕන කියලා දෙපැත්තටම යනවා. Got it? So therefore, it's a wrong practice. experiment. So therefore, when questions are coming, that's a very frequent question that is asked from you always. Right? You have to know it. Always the liquid with higher density should be put first. Otherwise, if you do the other way, the liquid with lesser density spreads to both limbs. Right? Now, it should be put to the higher density. Yeah? Higher density. Liquid with the higher density should be put to the U tube first. Look at here. Okay, now this is the liquid with higher density. And then only you can put the liquid with lesser density. And we have to make sure that, listen, you have to make sure that this interface is not in the curved part of the U tube. Right? Because then that interface is not going to be horizontal. If that is moved to the curved part. So therefore, you have to keep your interface at the vertical limbs. Then YouTube එකේ vertical දෙකයි මෙතන මේ curve part එකේ තියෙන්නේ. Curve part එකට interface එක ගන්න බෑ. ගත්තොත් වැරදි. Right? So therefore, you have to make it sure we are the one and you are the one who are doing the experiment. Right? So interface should be on the vertical limb. Don't take it to the, we don't take it to the curved surface, because then the interface is going to be inclined. That is not horizontal. Right? Then the experiment will be erroneous. There will be errors in the experiment. Okay. Listen. Now, other than this, now this is the interface. Now, other than this, we have to have two half-meter rulers. Two half-meter rulers. What is that for? That is to measure these heights. Right? We'll be taking two half-meter rulers and we are fixing rulers close to the limb like this. We are fixing the ruler close to the limb like this. Right? And this side also, look at the board. This side also, we have to fix the ruler close to the limb. Now, this is the meter ruler. This is a meter ruler. A normal meter ruler, a half meter ruler. So, from that, we can read the readings. Two meter rulers. Like this. Right? Okay. Now, the purpose of fixing meter rulers is to measure heights. Otherwise, we can't measure these heights. We need H1 and H2. We need H1 and H2. H1 and H2. To measure it, we are using a meter ruler. Then, just behind the limb, we have a meter ruler. Then, easily, just by looking at the meter ruler, we can get the reading. Right? Reading here minus the reading here will be the height of the column. Simple as that. Right? Now, let's assume the reading here is x. මම Tute එකේ දීලා තියෙන labeling එකම use කරන්නම්කෝ. එතකොට ලේසියිනේ. See, reading here is x, and let's say reading of the meter ruler here is z, and reading of the meter ruler here is y. This is also same z. Right? Then x minus z will be x minus z will be this height. Let's label it as listen, I didn't explain you about the liquids we are using usually. Most frequent liquids, frequent in this is popular liquids we have in labs are, most popular one is, no doubt, that is water. Most popular one is water. Right? That's the easiest one to find. Most availability is with water. Right? So therefore, one side is water. Liquid with the higher density is water. We usually use water. In lab එකේ කරද්දී use කරන liquids water. And for the other side, we use coconut oil. Usually coconut oil. Right? Coconut oil නැත්නම් kerosene or something. Right? Usually coconut oil. Even though coconut oil is a little bit expensive these days, we are still using coconut oil. Right? So this side, this is coconut oil. experiment use kar muut wenna now. If you need to cook again, you can take it out and cook. Right? Muut wenna anything experiment ekata vitarai use kan to determine density of coconut oil. Right? Okay. Density of, all right. Okay, then let's label this as, don't write, just look at the board. Let's label this height as H oil, HO, and this height as HW, height of water. Right? H of oil and H of water. Right. Okay, now there's nothing beyond this thing. If we have an interface, we know pressures at the same level of the interface will be equal. Now we are going to equate pressures. We are going to equate pressures. And if I need relative density can be make in the equation, can be built up in the equation, and we are going to do something to find it out. Right? Okay. Let's see what we can do. Before that, next heading, did we write materials and apparatus? No. Okay, next heading, materials and apparatus. Next heading, materials and apparatus. Next heading, materials and apparatus. Interface means the separation of two liquids. Yes. Meeting surface of two liquids. Could you please explain again? I had network issues. Which part do you mean? So don't worry, I will explain again anyway. Right, materials and apparatus, and under that subheading materials. Under that subheading materials. Okay, write down one by one. A YouTube. A YouTube. Here. A YouTube. A YouTube. A YouTube. Second one, 2 half-meter rulers. 2 half-meter rulers. 2 half-meter rulers. Then these two. Coconut oil. Coconut oil. Coconut oil. Water. Water. And a set square. I'll explain why we are using a set square. Right? So in the list, write down set square. Set square. Okay, then apparatus. Next heading, apparatus. Next heading, apparatus. Apparatus. Take this down. Take this down. Take down apparatus. What's under PO in formula? That is not PO, that is rho naught. Rho naught. Hope you know rho. Rho, that is rho, density. Rho naught over rho water. Apparatus and setup. Simply, listen again. Simply, take a YouTube and fill the liquid with higher density first, and then fill the liquid with lesser density second, and make sure your interface is not in the curved part, curved surface, curved part of the tube, and fix 2 meter rulers close to 2 limbs of the YouTube, right? And then we didn't do anything. We are going to measure these heights. We are going to measure these heights that we will discuss in the method. Finished? Okay. Then method. Next head in method. Okay, write down with me. Since pressures at same horizontal level, since pressures at same horizontal level, you can write along with me, are equal. Since pressures at same horizontal level are equal. And label P naught here as well, P naught, and here also P naught. And I'll introduce P naught here. P naught is atmospheric pressure. Right. Now, let's say these points are A and B. This is point A. And let's say this is point B. Now, what we can say is pressure at A equals pressure at B. Pressure at A equals pressure at B. Pressure at A can be written as P naught plus HO. Let's assume the density as rho O, right? Let's assume this density as rho O, and let's assume this density as rho W. Rho OG equals P naught plus HW rho WG. P naught to P naught cancels, G to G cancels. So what comes is H naught rho naught equals HW rho W. Right. I'll erase this part now. Okay. See, now what we need is relative density, right? Relative density is the ratio between density of substance to density of water. No? Then rho W is my density of water. I have to create the term rho O over rho W. To create rho W, I'm going to divide this by rho W. Right? We are going to divide this by rho W. Now from the equation, I'm taking the equation again to here. Look at the board. Now the equation we have got is H rho O equals HW rho W. Right? To create the term, we can write this. We can write this like HO rho O over rho W equals HW. Right? Which means HW equals rho O over rho W times HO. Right? Okay. Now here I have created the term relative density. Rho over rho W. That is relative density. That is what we discussed in the theory. Right? Okay. Then when we are going to plot the graph, see, now we are going to change, listen, we are going to change the height of the liquid column of the lesser density, right? Now, if you do the other way, there is no point of doing that, because now if I add more water, what happens is interface goes up, but the liquid level above the interface remains same, right? If we didn't add coconut oil, so therefore always coconut oil will be added. Liquid with lesser density is added, right? So when it is added, both heights are changing, right? So therefore HO changes. So by manually we change HO, which means that is the independent variable X, right? So therefore HO is the independent variable X, right? Whatever it is as a product with X is the gradient here, and Y is changing accordingly with X. So Y is Y. Again, an equation comes as Y equals mx. An equation comes as Y equals mx. Right. Now, if we plot the graph, see, now if we plot the graph between instead of y-axis we have HW and here HO, and that will be in the shape of Y equals mx, like this. And now if we check the gradient, see, gradient, simple limb of the graph is rho O over rho W. Right? Now, what we can do is very simple as this. Look at here, gradient equals rho O over OW, right? And rho over OW is actual relative density, right? Which means after plotting the graph, when we determine the gradient of graph, gradient equals to relative density. Our target was relative density. Determination of relative density of a liquid using YouTube. Now, since we have the graph, we have a graph now, which means gradient of that graph is known. Can be determined. Points එකක් හොයාගත්තා y over x එකක් දැම්මා gradient එක එනවා. If gradient is known, which means relative density is known. Now from the graph, gradient is known. If that is known, when the gradient is known, relative density is known. Right? That's the end of the experiment. Very simple. Very simple. Right. Now, yeah, under method, starting from here, take it down all the way up to this point. Take it down all the way up to this point, and then we'll be writing the note again after this point. Finished? Slow down. Slow down කරන්න පුළුවන්. Slow down කරලා 2:30 කොහොමද ඉවර කරන්නේ? Now my plan is to finish all by 2:30. Right? Now if you can stay until like 3:34, I can slow down and do. Right? And this is not the speed. මේක නෙමෙයි speed කියන්නේ. Paper class එකේ නෙමෙයි බලන්න speed එක. මේ speed නෙමෙයි, this is slow. In my case, this is slow. Right? This is not the speed. Speed case එක මීට වඩා ගොඩක් speed. Right? This is average actually. මේ slow නෙමෙයි, this is average. This is average. Okay, finished? Okay, below this, write down with an asterisk mark, write down. Since gradient can be determined using graph, 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 relative density of liquid, relative density of liquid, relative density of liquid can be found. Relative density of liquid can be found. Relative density of liquid can be found. Right? Okay. That's it for the method. As the next heading, write down remarks / important points. Important points. Next heading, remarks / important points. Remarks / important points. Okay, first bullet point, that is about this I explained. Always the higher density will be put first. First point. Before that, about the immiscible thing I will mention. First point, can be used only for two immiscible liquids. Can be used only for only for two immiscible liquids. Can be used only for two immiscible liquids. Can be used only for two immiscible liquids. Second point, the liquid with the liquid with higher density, the liquid with higher density should be put into YouTube first. 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 Within brackets, within brackets, within brackets. Otherwise, liquid with lesser density, liquid with lesser density. Otherwise, liquid with lesser density goes to both limbs. Goes to both limbs. Otherwise, liquid with lesser density goes to both limbs. Close the bracket. Next point. Next point. Next point. Readings are taken by changing, by adding, Gillian. Readings are taken by adding. Readings are taken by adding. Readings are taken by adding the liquid with lesser density. By adding the liquid with lesser density. By adding the liquid with lesser density. Within brackets, otherwise, within brackets, otherwise, there won't be a change in liquid column heights. Otherwise, there won't be a change. Otherwise, there won't be a change in liquid column heights. Next point. Interface should not be at the curved part of YouTube. Interface should not be at. Interface should not be at. Limbs. Limbs कहने का हाल नहीं तो limbs. Limb. Right? What did I say? Interface should not be at the curved part. Should not be at the curved part of YouTube. Should not be at the curved part of YouTube. Next point. Next point. A set square. A set square. A set square. A set square can be used to. A set square can be used to. A set square can be used to increase accuracy of readings. Increase accuracy of readings. X, Y, and Z. To increase accuracy of readings X, Y, and Z. Okay, listen, if the set square is available, what we do is we can place the set square like this here. And if we keep that set square exactly in line to the water level, we can easily read what this division is without looking at the liquid inside always. Because in the liquid, we will see it through refraction that is inside the glass tube. Right? මෙම set square එක තියලා බලුවොත් තව පොඩ්ඩක් හොඳට රීඩින් එක ගන්න පුළුවන්. set square එකේ රීඩින් එක නෙමෙයි රීඩින් එකේ මීටර රූලර් එකේ. අරක ඉන්ඩිකේටර් එකක් විදිහට තියාගන්න. right? මෙහෙම set square එකක් තියලා මෙහෙම කරලා රීඩින් එක බලනවා. right? That increases the accuracy of readings. right? That's why I mentioned the list. Mention set square in the list. Right? Okay. That's it. So that's the end of practical 3. Right? That's the end of practical 3. Any questions? Any questions? What about you? All clear? Online students? Zoom, YouTube? Someone can answer for the questions regarding the note now, because I'm not looking at the note and giving you the note. I'm just keeping this in mind, thinking about this and giving the note instantly, right? So therefore, I can't recall that in exact words. Okay, clear. No questions? Feeling hungry? No. Feeling hungry? No. Yes. What about online students? You don't feel hungry because you had something in the class. Yeah, what about you? Online? What about the ones on YouTube? XYZ are readings. Yeah, readings. XYZ can readings. Now, if you need H note, maybe HO, okay? HO is X minus Z, and HW is Y minus Z. They are readings, right? I have put the same thing in the Tute as well. Why do we subject H of order to create relative density? To create relative density. Okay? Now this is relative density. Now you have to create this. This is the term relative density. To create it, you have to subject it. Now it will be automatically subjected when you create relative density, right? What else? Right. Okay, listen. Now it's 12:36. Listen. Okay, now from the plan today, now we have finished 3 practicals and 2 more remaining, right? The coming 2 practicals are very important when it comes to questions, because popularly they are coming as questions. Here's apparatus and weighted test tube, very popular question types, right? So therefore, don't miss the next part. Even if you are going out, come back to the class again, right? Because next 2 are very much important compared to the ones we discussed already, right? So there are 2 more remaining. Now it's 12:37, right? So let's say 12:40. Okay, now it's 12:40. Now it's 12:40. So I'll be giving you 30 minutes from 12:40 to 1:10, right? So please come here by 1:10. We'll be starting at 1:10. And for boys, if you are going to pray, I hope 30 minutes is manageable, right? So please go and come back by 1:10 p.m. Right? All right then. Okay. So go refresh yourself, have a meal, refresh yourself, have something, and come back. Okay, I'll be starting sharp at 1:10 because my plan is to finish the session by 2:30. Otherwise, we will be running out of time, right? So therefore, I'll be starting sharp at 1:10. Okay, right. Washrooms are in the second floor. Right? Second floor okay, right. Take it second floor. Okay, we'll start. Okay, we'll start. Okay, I'm audible, right? Online students? Okay, now it's 3 minutes past 1:10. So I hope the time is enough. Because today there are more things to be discussed remaining. 2 experiments remaining. There are more things to be discussed there. Right. Okay. Okay. Right. Practical 4. 4. Right. Okay. So you had something? Meals, you had something and refreshed. Okay. So I hope online students are also refreshed. And now I'll be continuing straight until the end, right? Until the end, we'll be continuing straight, right? So again, make yourself comfortable with the class because we are going to continue until the end of the class, right? So I have planned to do 30. So let's see how it changes. Yes, how it changes in the sense now if you do these things faster, if you grab these things faster, it'll be a little bit earlier than 2:30, and the opposite is also like that. Okay, 1:15 now. We'll start. Next one. Okay, heading, write down determination of relative density. Determination of relative density of a liquid using Hare's apparatus. Using Hare's apparatus. Using Hare's apparatus. Give me 1 second. Right. Okay, now to determine relative density, listen. To determine relative density of a liquid, there are 2 methods. We have 2 experiments we have, right? One of the experiments was the previous one using YouTube, right? And this is the second one using Hare's apparatus, right? So the respective theory part is we have something called a setup called Hare's apparatus in our labs, in school lab, right? Have you seen Hare's apparatus? No. The respective theory part is this. Respective theory is we have something called Hare's apparatus. It is something like this. Look at the board. This is a setup. Huh? This is a setup. And here there's a valve. And then these two tubes are dipped in a container like this. They are dipped inside a container. They are dipped inside a container like this. Right. Here, there is one advantage over a YouTube. That is, we have two different containers to put liquids in. So therefore, this is especially designed to find relative density of two miscible liquids. Okay? Two liquids are not going to be in contact. Now, when we insert a liquid here, right? And when we insert a liquid here for these two, right? After inserting the liquid, then what we have to do is we can open this valve from here, right? After opening the valve, we have to suck air out by mouth, right? There are two methods, by mouth or by using a syringe. But for by using a syringe, the last time no marks were given, because usually how we do is we are releasing this and sucking air out by mouth. Right? Then we well at the right? Then katadila din no. Katadila air එක පම්ප් කරලා එළියට දානවා. පම්ප් කරලා එළියට දානවා කියන්නේ මෙතනින් අපි අදිනකොටම මෙන්න මේක දිගේ මේ ලික්විඩ් එක එනවා. Right? Remove this valve from here and suck this air out by mouth. Then once we do so, this liquid here rises up through this tube, and the liquid here also rises up through this tube. It will be something like this, which means what we are doing is, now initial this part is at atmospheric pressure, but if we suck air out, that pressure reduces. When pressure reduces, the liquid rises from high pressure to low pressure, right? Sucking air out means the pressure will be reduced from atmospheric pressure, right? Because higher number of air particles means higher pressure, right? If you are doing chemistry, you will know it by now. Now, for us also, we have those kind of gas parts in thermal physics, right? So now we are here after mechanics. So just know that lesser the volume of air, lesser the pressure at the same temperature, right? That's the thing. I just started, take down the heading, and that's it. I didn't ask to take down anything here. Oh, that's what. Okay. Okay. So now, once this air is sucked out, listen again. Now in Hare's apparatus, we have one curved tube like this, and these two parts are vertical. Now these like an upside down U tube, but here there is another mechanism with a valve, right? And these two are two beakers. They are two beakers, and we can put the liquids that we need to consider here into the beakers, right? And opening this valve, we can suck air out using by mouth. Then these two rises up along the limbs, right? Okay, and again we have to close the valve. Once it is closed only, it will be still like this. Otherwise, if it is open, again it is coming to atmospheric pressure, it goes down, right? So therefore, we have to just open it, suck air out, and close it again, right? Now the setup is like this. Setup will be like this, right? Look at here. Now this is open to atmosphere from these ends. So P naught tax. Here also P naught tax, because these beakers are open to atmosphere, right? And let's assume the liquid height here as H1, and the density of the liquid as ρ1, and the height of the liquid here as H2, and the density of the liquid as ρ2, right? Now, here this is an air medium. This is an air medium. Pressures at any point of an air medium is same or different? Pressures at any point of an air medium is same or different? They are same, right? Now this is a closed room. Pressure at any point of this room is same. That is an air medium. Atmospheric pressure, right? So in air medium, pressure doesn't change. That is same. Now this is also an air medium. So that is same. I'll assume the pressure at air medium here as P dash. Let's say P dash. Right. This is the theory. Look at the board. Now we can write P dash starting from left side here, left limb here. This is P naught. P naught. And we know pressure difference through a liquid column is given by H rho g. Downwards plus H rho g, upwards minus H rho g. Now P naught is here at this same level. Now we have to go up. We have to go up. Going upwards means minus H rho g. Then here minus H1 rho 1 g equals, now we add this level, which means P dash. Right? Same thing using the right limb. This is at P naught. And we can go up until we reach the gas medium. Going upwards means H2 rho 2 g. Now again, that is at the gas medium. Now these are two equations for same P dash. No? So therefore these two are equal. 1 equals 2. 1 equals 2. 1 equals 2. P dash equals P dash. Which means from this side, P naught minus H1 rho 1 g equals from the other side, P naught minus H2 rho 2 g. Right? P naught to P naught cancels. Minus H1 rho 1 g equals minus H2 rho 2 g. G to G cancels. And minus to minus also cancels. Right? So what remains is H1 rho 1 equals H2 rho 2 again. This is called the principle of a Hare's apparatus. Right? So the advantage of using Hare's apparatus is it can be used to compare two miscible liquids. YouTube එකෙන් mix එකක් කරන්න බෑ. Right? For YouTube it should be two immiscible liquids. For Hare's apparatus, any two liquids, it doesn't matter whether it's miscible or immiscible because they are on two separate containers. They are in two separate containers. Clear? Right? That's the theory part. Okay, as a theory, take this down. As a theory, take this down. I have to go far. Now that so exactly in front of here, Amrita, it's Tamil. It's open. No, I don't think yogurt drinks are. Yeah, people are yes. That's close. Then to where you went? I see. Right. Duplication road. Then you didn't find anything for yourself. Right. Finish. Take it down. Take it down. Finished? What about the online students? All good? Any questions? Finished? Okay. Look at here. Look at here. Now this is a setup we have in the lab. See, now we have this in the lab. Now again we are taking the Hare's apparatus setup. We are taking the Hare's apparatus setup. And for these two containers, we have to add the two liquids that we are going to compare. Right? We are adding two liquids that we are going to compare. Okay. Any two liquids can be used. Any two liquids can be used. So here also I will consider coconut oil and water. Right? Any two liquids can be used. That doesn't matter. Right? With the popularity, I'll be using coconut oil and water again. Any two liquids can be used because this is valid for any two liquids. Any two liquids. Right? So as one of the materials, we need Hare's apparatus. That's an apparatus we have. Hare's apparatus. And this side, let's say, I have inserted oil. Right? Let's say an oil. And this side, I have inserted water. This side, I have inserted water. Right. Now, once these two are put into the containers, listen, this part is important. Once these two liquids are put into the container, right, into containers, what you have to do is we have to remove this valve from here. This is a valve. This is a valve here, right? So we have to remove this valve from here and we have to suck some air out, right? Not all, suck some air out until this rises up and close the lid again. Close the valve again. We have to close it firmly. If there are leakages, again the liquid goes down. Because if there is a leakage, again the pressure changes inside. We have to keep the pressure constant. So tightly keep it after closing, and once it is sucked out, you can see this liquid rises up along the length, right? At the same time, both rises up, and this one also rises up along the length, right? Now in Hare's apparatus, to see these liquid levels properly, to identify these liquid levels properly, another index is used. Index in the sense, we are using a bent pin. We are using a bent pin or a needle. A bent pin or a needle. And that pin is connected to here, like this. That pin is connected to here like this. The purpose is, let me draw here again. The purpose is, without looking from the top, now like this and like this. Without looking from the top, they are called index, index. Without looking from the top, now this is with a movable rubber band. Movable rubber band. We can take it up and down easily, right? So once this is closed again, we are taking this until it just touches the water surface. Right? And for the other one also the same. And here also we have to have a scale. And in some Hare's apparatus, listen, in some Hare's apparatus, the scale is already mentioned in the board. In some, that is mentioned already in the board. And if not, we have to use meter rulers as the previous one. Right? Let me draw meter rulers. Now, when we are using meter rulers, there will be meter rulers here. Half meter rulers. Meter rulers can half meter rulers like this. And here also. That is to take readings. Meter rulers. Right. Take it down first. We didn't write materials. Okay. Next heading. Materials and apparatus. materials and apparatus. Next heading, materials and apparatus. Materials and apparatus. About using pins, this is the logic. Listen. About using pins, the logic is this. Now, when we look through the glass tube, glass container here, we will see it through a refraction. There's a refraction of light due to glass. So therefore, there is a possibility of having a deviation of the reading we read. Right? There's a deviation because of the refraction. So therefore, this precaution is used. මේ පින් එක ගන්නට මෙහෙම පාත් කරලා තියෙනවා. right? පින් එක පාත් කරලා තියෙනවා. ඊට පස්සේ මේ රීඩින් එකයි මේ රීඩින් එකයි ගන්නවා. see? Now this is on air. This reading is on air. On an air medium. So therefore, this reading can be taken. Let's say x1 or x කියමු. Let's say x. right? The x1 and මේ රීඩින් එකක් ගන්නවා. Let's say x2. And this is starting point of the needle is also at air medium. මේකත් ගන්න පුළුවන්. Let's say x2. මේකත් ගන්න පුළුවන්. y2. Sorry, x2 දාලා y1 y2 කියලා දාන්න. See? y1 and y2. And then after removing these water containers, we can measure only this part freely. Without any refraction, without any disturbance from refraction. මේ part එක දන්නවනේ. මේක ඇඩ් කරලා අපිට ගන්න පුළුවන්. That's the benefit. That is how it increases accuracy. Otherwise, if you try to measure it at once, there will be errors because of refraction. There are errors because of refraction. That is why a pin is used. Right? Pin එක විතරක් වෙනම measure කරනවා මේක අයින් කළා. We can remove after the experiment, after these readings are taken, we can remove these water containers and we can measure this height of the pin later on. So let's assume, look at here, let's assume this rho O, rho W. And let's assume height of this part is this part. Let's say height of this part is HO dash. Right? Listen. And height of the pin here is, let's say, H1. Now HO here. Let's go the other way. HO and HO dash. See? HO and HO dash. Let's see. Right? And this side, let's say, height of this column here, let's say HW. Right? And height of this part of the needle is H dash W. Now when I need the total height, it can be obtained by H0 plus H0 dash. This is HW plus HW dash. Right? So that is higher in accuracy. That's the benefit we have. That is higher in accuracy. Because we have omitted the impact from diffraction. So likewise, if that is possible, we will go ahead with that. Right? Then capillary tube එක ඇතුලේ තියෙන එකක් නම් අපිට එහෙම කරන්න බෑ. හැබැයි දැන් මේක අපිට ඇඩ්වාන්ටේජ් එකක් තියෙනවනේ මේක තියෙන එළියේ තියෙන කන්ටේනර් එකනේ. ඒ හින්දා මේ වැඩේ කරනවා. To get more accuracy. Is that clear now? Right? Okay. Finish taking now? No, we didn't write. Apparatus and materials and apparatus. Okay, under that, first heading, materials. So under materials mention, first one, Hare's apparatus. Hare's apparatus. Next one, two liquids within brackets, Two liquids within brackets, oil and water. Two liquids within brackets, oil and water. Next one, 2 half-meter rulers. 2 half-meter rulers. 2 half-meter rulers. Next, 2 bent pins. 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 Right? Okay. Next heading, apparatus. Next heading, apparatus. Sorry? Immiscible liquids can be put into U-tubes only. Immiscible means not mixing. For both, these two liquids are not in contact. These two liquids are not in contact. Any two liquids can be used. So especially we are using Hare's apparatus over U-tube for miscible liquids. Miscible නම් ඉතින් මේක ටිකක් ලොකුයි YouTube එකට වඩා. මේ setup එක ලොකුයි. මේ වගේ ලොකු setup එකක් use කරන්න නැතුව YouTube එකෙන්ම වැඩ කරගන්න පුළුවන්. මේක ටිකක් විතර ලොකුයි මේ වගේ setup එකක් මේක. Right, this is high in size compared to the YouTube. Is it compulsory to use immiscible liquids? No. See, I told you any two liquids. Any two liquids. Right? Any two liquids. Finished. Finished. Okay. Now, with this same apparatus, now we are applying this theory. Now, this is a theory with the Hare's apparatus, right? So, therefore, so let's assume pressure at here as P dash again, and atmospheric pressure as P naught. Atmospheric pressure as P naught, right? So, we can apply the theory like this. Look at here. You can apply the theory like this. From left limb, P naught minus, now we can go up, HO dash plus HO rho OG. Let me write somewhere here. See, same theory. P naught minus, when you are going up, minus HO dash plus HO rho OG equals, other side, P naught minus HW dash plus HW rho WG. Right? Simplify this. Once this is simplified, you can take this up to here. HO dash plus HO times rho O equals H dash HW dash plus HW times rho W. Right? Okay. Now we are going to plot a graph again. Right? We are going to plot a graph again. To plot the graph, these heights should be changed. To change heights, what we do is, we can, listen, this is a different one, very important one. We can slightly open this valve again and let air comes in. Once we let air comes in, these two goes down and again closing. Again letting air comes in and again closing. So likewise, we have to take 6 different readings. Right? Then mega I open කරන්න මෙයා පල්ලෙහාට යනවා. මෙයා atmospheric pressure එකෙන් pressure එක ඇතුළට එනවනේ. From atmosphere, it will get some pressure inside when the valve is open. So therefore it goes down again. It goes down. Now let's say initially it is at 6 centimeters and 4 centimeters. And if I open it again, it goes down. Then it will be like 5 centimeters and 3.5 centimeters. So likewise, it goes down. Such 6 readings should be taken to plot the graph. Such 6 readings, right? Initially, we are sucking and closing, and then when the experiment is done, we have to open it 6 times and get 6 readings. Open it 6 times and get 6 readings. Right? Is it clear? Now, I'm going to create. Now, what's the purpose here? We need relative density of the liquid. Since we need a relative density, again, I need to create rho over rho W. To create rho over rho W, do a simplification here. Do a simplification. See? Now, I'll be simplifying this equation. Here. Need to create rho over rho W. See? Then HO dash plus HO times here rho O over rho W equals, from other side what remains is H dash W plus HW. These dash values are constant values, no? Because they are the length of pins. Length of pin is a constant. Even though the liquid height changes, height of the liquid changes, length of pin is a constant. Length of pin is a constant. So therefore, variable is going to be what? HW. And from this side, variable is going to be what? HO. HO is my variable. See? Now, we can simplify this like this. You can simplify this like this. Now, in this side, we have HO dash times rho O over rho W plus this is HO times rho O over rho W plus this is H dash W plus HW. I'm going to change sides. Subject HW. HW equals here rho O over rho W HO, right? Plus rho O over rho W HO dash, when this is taken to the other side, minus HW dash. Is it visible? Yeah, visible. Okay. Now, the term that we wanted to create is created already. Now we can identify the shape here of the graph. Now, this is my y variable, y, dependent variable. And this is the independent variable, x, right? Whatever it is as a product with the independent variable is the gradient. So this is gradient. And this entire part that is added after the independent variable is called intercept, C. So therefore, what we are getting is a graph of the shape, standard shape, y equals mx plus c. Our graph is y equals mx plus c, right? Now from this you can see gradient is again rho over rho w, that is relative density. Now කොහොම හරි readings පාක් කරගෙන graph එක ගහගත්තා නම් වැඩේ ඉවරයි. Graph එක ගහගත්තා නම් if you can take 6 readings and if the graph is plotted, which means gradient is known. If gradient is known, relative density is known. Clear? Okay. Now where did we stop? Materials. Okay, then apparatus. Next heading. Didn't you draw the apparatus? You draw, right? Apparatus killer. Okay, now apparatus is drawn. And below that, write method. Write down method. And starting from here, copy it down up to this point. Starting from here, copy it down up to this point. Starting from here, copy it down up to this point, y equals mx plus c, until the equation. Dylan, you have to take this down. Finished? This experiment is a little bit advanced compared to YouTube. YouTube is a very simple setup. No? YouTube is a simple setup. Simple in the sense there's nothing at all. Very simple. But here, the setup is a little bit advanced. Right? If we are dealing with two miscible liquids, this is the only option we have. So we have to go for it. Right? Here's apparatus. And we discussed the questions of Here's apparatus in hydrostatics. Right? So there the theory was discussed. I just recall the theory again today. Finished. Okay. So mention the method one by one. First point. Insert two liquids. First point. Insert two liquids to be considered. Insert two liquids to be considered. Insert two liquids to be considered into Here's apparatus. Into Here's apparatus. Into Here's apparatus. And suck some air out. And suck some air out. And suck some air out. And suck some air out through valve by mouth. Through valve by mouth. And suck some air out through valve by mouth. And close the valve again. And close the valve again. And close the valve again. Right. Next point. Apply the principle of Here's apparatus. Next point. Apply the principle of Here's apparatus. Apply the principle of Here's apparatus. Apply the principle of Here's apparatus. Okay. Now look at here again. Look at here again. From above equation. Don't write, look at the board. From above equation. Right? Now if we plot the graph. Now the graph is y equals mx plus c, no? Mx plus c. It will be like this. Y is hw. And x is ho. Right? This is a mx plus c graph. And gradient of this graph will be gradient, let's say m of this graph is, according to the proof, rho over rho w. Right? Which means if gradient is known, this is known. Right? Once the graph is plot, that's the end of the experiment. Graph anything, that is just a matter of determining the value of gradient. If the value of gradient is known, relative density is known. Right? Okay, start from here. From above equation and then come up to here. Finish? Okay. Then write down here. Write down here. Since gradient of graph can be determined, since gradient of graph can be determined, relative density of liquid can be found, right? Since gradient of graph can be determined, relative density of liquid can be found. Relative density of liquid can be found. Relative density of liquid can be found. Right? Okay. Then again, as in extending, write down remarks / important points. Remarks / important points. Remarks / important points. Remarks / important points. Okay, first point, first bullet, write down. Hare's apparatus can be used to. Hare's apparatus can be used to. Hare's apparatus can be used to compare densities of two miscible liquids. Miscible. Two miscible liquids. Within brackets, this is an advantage over YouTube. This is an advantage over a 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 YouTube. Right. Next point. Next point. A bent pin is used. A bent pin. A bent pin is used. A bent pin is used to avoid impact from refraction. To avoid impact from refraction. To avoid impact from refraction when taking readings. Okay, right. So that's it for Hare's apparatus. So that's the end of practical 4. That's the end of practical 4. And we are going to move on to our last practical for today, practical 5. So before that, any questions? Understood? All good? You? Online students, any questions? Quickly. Before moving on to practical 5, last practical for the day. Last practical for the day. Before moving on, any questions before erasing the board? All good? Last note. Someone please send the note to the chat. No, clear. Okay. For all of you, is it clear? Right? Okay then. Then we are moving on to the last one. In questions, what if a liquid other than water is used? Totally fine. Totally fine. I told you any two liquids, huh? Any two liquids. For any two liquids. Any two. Any two means any two. Water is used with the popularity. Right? Availability. Right. Okay then, let's move on. The last experiment, last practical for the day. Write down practical 5. Practical 5. Okay. Practical 5. Write down determination of density of a liquid using determination of density of a liquid using weighted test tube. Weighted test tube. Using weighted test tube. Okay. The respective theory part is this. Look at here. Respective theory is law of flotation actually. Law of flotation. Look at here. Now, if a test tube floats, if a test tube floats in a liquid like this, if a test tube floats in a liquid like this, right? Let's say total mass of this tube is mg, right? And from water we know upthrust acts here, right? So by law of flotation we know, by law of flotation we know this is in a vertical equilibrium. So therefore, what law of flotation suggests is u equals mg when an object floats, right? There are 2 points satisfied by law of flotation. Upthrust equals weight and center of buoyancy and center of gravity are on the same vertical line, right? Now, using law of flotation, see, by law of flotation, vertically upwards forces equals vertical downward forces. Vertically upwards, that is only u. Vertical downwards, mg, right? And u can be expanded. Sorry, u can be expanded as v rho g, right? So which means if this immersed volume is v, if the immersed volume is v, this can be written as v rho g equals mg, right? This is the associated theory part here, the respective theory part here. Now let's see how this is going to use in the calculation, in the experiment and the determination. Okay, as a theory, take it down. As a theory, take it down first. Take it down as the theory. Law of flotation. It comes from law of flotation. Finished. Stay vigilant until the last one. Now, after today, you don't have anything to know about these 5 practicals we discussed, right? refer these things again and again. And I have mentioned the past paper questions that have been already come. So you can try questions and see how the questions are asked. Right? How all theories are covered. And if I got a free time later on, I'll be conducting a discussion on the past paper questions on these experiments as well. But during these 2 months, it's not that sure. The thing is, with the 25 classes, I'm a little bit busy these days. Right? Because now for 25 students, this is the 9th week ongoing. They have just 8 weeks remaining for the exam. Just 8. Right? Just 8 weeks before the exam. Registrations. Oh, sorry, I forgot to mention actually. Yeah, about the registrations, what you can do is, one thing is, now my website is working. You can go to this website, psphysics.lk, and you can create an account and register the class, enroll to the class there, or else for any other inquiries, you can contact that number. I mean, my number, contact through my number or the hotline number here in Machma Institute if you are joining to Machma. If you are an online student, you can just go there and get register yourself. Right. Okay, look at here. Now, this is how the setup is going to be used. See, look at here. Now, final target here is determination of density of a liquid. Then, which means density of that liquid is unknown. That is why we are going to determine. Right? So, therefore, we are not going to consider water like a liquid here, because that is anyway a known liquid. We don't consider water. See, now we have to have a tall jar like this. A tall jar. Look at the board. Don't write, just look at the board. A tall jar. And the test tube. Where a test tube? The test tube. This is the test tube. Right? And here we do something like this. This curved part of the test tube is filled with either iron balls or, now I explained you two things we need: a tall jar. One is a tall jar, right? And then we need a test tube. We need a test tube. And now here we have a curved part for any test tube. No? This part is the curved part. Look at the board. There's a nice idea here, right? This curved part, we are filling it with either iron balls or lead shots. Lead shots. Have you seen iron balls? Iron balls? Bicycles එහෙම තියෙන්නේ. Bicycles එහෙම දන්නවා පොඩි කාලේ. පොඩි කාලේ bicycles වල එහෙම ගලේවම දැකලා නැද්ද මේ iron balls තියෙනවා handle එක වටේ. They are called iron balls. Anyone? Haven't seen iron balls? See, Viroji, why taking for you? U equals Viroji. Upthrust. Haven't you seen iron balls? Oh, okay. There is something called iron balls. Very small balls. Pebbles, like pebbles. That is made of iron. That is called iron balls. Right? What we do is, we are filling, look at here, we are filling this thing, this part with iron balls. This curved part with iron balls. Look at here. Filling this curved part with iron balls, and wax is used to seal this area, and we are using wax, melt wax to seal this area like this. Iron balls dala meka seal karala dana. Got it? It is filled with iron balls and then sealed with wax. Right? Now, from here onwards, here we have a scale. We are pasting a scale. Scale like on the glass tube. On the glass tube, Now, after this point, now this vertical part starts. All curved part is covered with the wax now, right? And this scale is only for the linear part of the tube, right? Calibration is only for the linear part of the tube, right? Then, now we have a liquid to determine density. That liquid will be filled to this tall jar, like this. And now this is filled with that liquid. Let's say density of that liquid is rho. Density of that liquid is rho, right? Now, using this scale, we can measure this height easily when we need. Let's say L, right? Once we need to measure this height, easily we can measure it using the scale here. We have pasted the scale, right? Otherwise, now when this tube is floating, when the test tube is floating inside jar, you can't insert any meter rulers or half meter rulers into that and do it. That is not practical, because when the meter ruler hits with the test tube, this equilibrium will be like it's waving. Equilibrium is breaking, harming. We are harming the equilibrium. So therefore, we have pasted the scale there. No questions. Right. And let's consider area of this tube as area, cross-sectional area of the tube as A. Right? Okay. Cross-sectional area of the tube as A. Right. Now, let's first mention the materials. Next heading, write down materials and apparatus. Next heading, materials and apparatus. Materials and apparatus. Materials and apparatus. Okay. Subheading, materials. Subheading, materials. So will it be floating without turbulence? Yes. That's law of flotation. And when this is heavier, now with iron shots, with lead shots and iron balls, now this part is made heavier. So therefore it floats. It's stable. Right? Materials, mention one by one. First one, a tall jar. A tall jar. A tall jar. Next one, a test tube. A test tube. A test tube. Then iron balls or lead shots. 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 Right? Then a small quantity of wax. A small quantity of wax. A small quantity of wax. And next, few mass units. Few mass units. I'll explain why we are using mass units. Write down first. Few mass units. Few mass units. Next one, last one, a liquid of which density should be determined. 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 Okay. Look at the board. Look at the board. Right. See, now this empty test tube with lead shots or with iron balls, this whole thing has a mass, no? So let's consider that as capital M, right? Let's consider that as capital M. Then mass of this part is mass of this part, capital M, I'll mention here, capital M, mass of test tube with iron balls. Mass of test tube with iron balls, capital M. And now we are using some additional masses here to load onto this tube. Loading means now using a string, using a small string, we are loading masses into the test tube like this. Additional masses, right? Once an additional mass is put, simple M, let's say, additional masses. Right? Once a mass is put, since mg increases, see, according to the equation, since mg increases, since weight increases, this goes down further. This immerses down further. Right? Which means now we are changing m. We are changing mass of the system. Changing variable is going to be the independent variable. And accordingly, immersed height is going to be changed. Immersed height is going to be changed. Then L is going to be dependent variable. L is going to be the dependent variable. Right? Now, considering that, we are going to apply this theory again. Apply law of flotation again. Right? Now, there are two masses. There are two masses. Capital M here and simple M here. Then altogether, total mass of the system is M plus mg, no? That's clear. Total mass of the system. Right? And upthrust acts on the system. Let's consider the upthrust as U. I'll consider the upthrust acts on the system as U. We'll mark somewhere here. Upthrust act on the system as U. Upthrust act on the system as U. Right? Okay. Look at the board. Now, according to law of flotation, according to law of flotation, vertically upwards forces equals vertically downwards forces. Right? Vertically upwards, U again, and downwards, now 2m's, M plus M, G. Right? We know upthrust can be expanded as V rho G. Upthrust can be expanded as V rho G. Right? And V is the immersed volume. Where V is, if anyone don't know these meanings, now if you are in 26 batch, there is no way that you don't know these things. This is called immersed volume. Immersed volume. Immersed part. Immersed volume. Right? Now immersed volume is the volume of the curved part plus the volume of this cylindrical part. No? Now, this is a tube. There's a curved part. There's a curved part at the bottom like this. And here is a cylindrical part. Right? So the total volume is the curved part's volume plus the cylindrical part's volume. Right? So I'll assume volume of the curved part as V. Volume of curved part. I'll assume volume of curved part as V. Now, if volume of curved part is V, we can write this volume. I can expand this volume. See, this is V total. V total volume into rho G equals M plus M G. G to G cancels. Total volume consists of volume of the curved part plus volume here. And we know if there is a uniform cross-sectional area, volume can be written as cross-sectional area times length. That's a normal thing. Volume can be written as cross-sectional area times length. Okay. Then this total volume is V of curved path plus V of cylindrical part. V of cylindrical part. Rho equals M plus M. Right? V of curved path is already considered as V. Right? Look at here, very important. V plus V of cylindrical part can be written as AL. If cross-sectional area is A, that is AL. Rho equals M plus M. Now, what is the changing variable here? Independent variable? Independent variable is simple M. Simple M. And with that the dependent variable is L. L is here. Now here onwards, the target is subject in L. Target is to subject L because L is the dependent variable. L is the dependent variable, subject L. Now hereafter, this is just a matter of subject in this. See, subject L. Now V plus AL equals M plus M over rho, right? And AL equals M plus M over rho minus V. I'll do the rest here. Right, then subject L by dividing the entire equation with A, right? So L equals M plus M over rho A minus V over A, right? Now we can divide these two terms separately. M over rho A plus simple M over rho A minus V over A. Now since this is my independent variable, now I'm going to separate this independent variable. See, L equals, take it somewhere here, 1 over rho A times M plus this part is M over rho A minus V over A. Okay, now we have taken this equation to one of the standard forms. This is my X, and whatever it is as a multiplier product with X is gradient, and this entire part added here is C, intercept. This is Y. So finally, the equation has become Y equals mx plus C. If there is an equation of Y equals mx plus C, we can plot a graph by changing M values again to 6 instances. Now we have, I mentioned, we have few mass units. So by adding 1 by 1 mass units, we are taking 6 readings again. If 6 readings are taken, we can plot the graph between. I'll plot the graph after erasing this. We can plot the graph between. Shall we draw here? We can plot the graph between simple mn L. Right? Then accordingly, you have few points and a graph mx plus C. You have few points with a graph like this. Right? Okay. So let's see how this is determined using the graph. Now that is the idea. By adding masses 1 by 1, mass can be changed. If mass is changing, independent variable will be mass, and then accordingly L changes. When L changes, that is the dependent variable. So we can plot the graph between M and L. Right? So always in experiments, we are always trying to plot graphs somehow, because that is how accuracy can be increased. When we plot a graph, accuracy is increased. Otherwise, if we just use an equation for a given instance and do something, there is only one instance of less inaccuracy. But here now we have dealt with 6 instances plus dealing with a straight line, a graph. By considering 6 points, we are plotting a graph. Right? 6 points are bias. There's no bias points there because we are plotting the graph as it is unbiased for all 6 points. Right? Okay, where did we stop? Only materials. Okay. Then apparatus. Next heading, apparatus. Write down next heading, apparatus. Next heading, apparatus. Write down the heading, apparatus. Now I think it's clear. It's clear to you that compared to first 3 experiments we had, last 2 experiments are kind of advanced. That's why I told you. When it comes to questions also, questions from these 2 are very popularly coming. Right? These 2 are a little bit advanced compared to first 3. First 3 were very easy. Right? Apparatus. Take this down. Take down the apparatus. Take down the apparatus. Take down the apparatus. This part. Don't write the method apparatus. Write down the apparatus. Just the apparatus, don't write the method. And if iron balls are not available as a substitution, we can fill this with sand. That is also possible. Iron balls නැත්තම් මේක කරන්න නැතුව ඉන්න ඕනේ නැහැ. sand දාලා ඒක කරගන්න පුළුවන්. No, because this is heavier now. This side is heavier, so therefore it's stable. Right? Otherwise, if this is not filled with iron balls, that is toppling. That's toppled. That is not stable. Now, once we filled it with iron balls, this bottom is heavier now. So it's stable. It's stable. That is why iron balls or lead shots are used. So we can take V as height. No, V again volume. So YV is object L. L is the dependent variable. Before y equals mx. Subject L. Subject L. So for materials, one meter ruler come under. So for materials, one meter ruler come under practical number 5. No. First four practicals are vernier caliper, micrometer screw gauge, spirometer, traveling microscope. It's even hard to understand. That is because you are from 27 batch, right? Otherwise, law of flotation and these things we have covered in theory classes, right? That's what I told you now. Compared to first three experiments, these last two are a little bit advanced. There are something to think of. There are something to think of, right? Now, knowing theories is a basic thing, right? I told you at the beginning, knowing theory is a basic. Now, anyway, I recalled you the theory because to anyone to recall the theories, even if you have done or if you haven't done, just to recall. Okay, finished? Right. Mention these three. Capital M, test tube with iron balls. Mention these three. Simple M, additional mass. V, volume of curved part. Mention these three as well. Mention these three terminology. These three terminology. Mention these three terminology. Mention it. Right? Okay, under apparatus, write down first point. First point. First point, fill test tube with iron balls. Fill test tube with iron balls. Fill test tube with iron balls. No, under apparatus. Under apparatus. Point 1. Under apparatus. Point 1. Fill test tube with iron balls. Fill test tube with iron balls. And seal it using wax. And seal it. And seal it using wax. Seal it using wax. And seal it using wax. Next point. Next point. Paste a millimeter scale. Paste a millimeter scale. Paste a millimeter scale Paste a millimeter scale on test tube. Paste a millimeter scale on test tube. Paste a millimeter scale on test tube. Right? Okay, then method. Next heading, method. 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 Right. Now start from here and take down up until the graph. Right? Metherin passe line එක මෙතන තියෙන්නේ. Right? Starting from here, take down up until the graph here. And when you have space below this, you can plot this graph below y equals mx plus c. Right? So below y equals mx plus c. Right. Take it down. Take it down. Send me your questions if there's anything. Now we are in the last experiment. Last experiment in mechanics. Last experiment in mechanics. And I'm repeating again. Now you can see the impact of graphing knowledge when it comes to experiments, right? So this is everything based on graphs, graphing. So therefore, if you don't know graphs, now it's, if you are 26, that is too late, right? So therefore, the video of the previous class I had on graph plotting is still on the channel. So please go there and watch it and make yourself comfortable with graph plotting. That is an essential skill you have to have when you are going to the exam, right? Now, if you are not familiar with these graph shapes, identifying variables like this, mx plus c, y, so those things, if you are not familiar, right? Go and watch that video and make yourself comfortable. That's a must. That's a must. Finished? Here. V total. Here. V curved plus V cylindrical. Right? Listen all. Here this is V total. Total volume. V total. This is V curved. V curved කියන්නේ මේ part එක. V curved plus V cylindrical. Cylindrical කියන්නේ මේ part එක. Because the test tube consists of one curved part and a cylindrical part. Right? And total volume can be written as the addition of these two. Why is wax used? To seal iron balls. To seal iron balls. Otherwise, there will be voids remaining inside iron. Voids, empty areas. Void remains. So therefore, to seal it, wax is used. Then wax is going into those voids and it will be sealed without having any air bubbles inside. Air bubbles video make a varadino. There will be errors in the experiment if there are air bubbles inside. Right? So it should be completely covered, sealed using wax. Ekai wax use karanga. Wax melt kala දාන්න ඕනේ. You know, when wax is heated, it gets melted. So then it can be poured onto the tube and sealed. Poured into the test tube and sealed. Right? Finished? Okay. Then write down first point under method. First point, write down. At weight units, one by one, at weight units, one by one, into the test tube, slowly, with the help of string, with the help of string, with the help of string, with the help of string. Next point, take 6 readings, take 6 readings for L, take 6 readings for L, take 6 readings for L for 6 instances, for 6 instances, for 6 instances. Right? Next point, plot the graph between, plot the graph between, plot the graph between, plot the graph between M and L. 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 Okay, now plot the graph, plot this graph there, plot this graph, plot this graph, and mention gradient like this. Gradient, let's say M. Now from this you can see gradient of graph is, right, gradient of graph, simple M is, see, this is the gradient, this is the gradient of graph, 1 over rho A. Gradient of graph is 1 over rho A, right? Now we are determining density of the liquid. Rho should be determined. Subject rho. So rho is 1 over M times A. M is gradient. M is gradient. M is gradient. Gradient. Gradient times A. Now, in order to determine density of the liquid, we are lacking another data. What is it? Rho is 1 over MA. We need A. We need cross-sectional area of the tube now. That's the idea. We need cross-sectional area of the tube now. Which means cross-sectional area of the tube should be measured. It should be measured. How we can determine cross-sectional area of a tube? Tell me, using measuring instruments. Simply using a vernier caliper we can do. External jaws of vernier caliper. Using external jaws of vernier caliper, you can get the external diameter. If external diameter is known, then cross-sectional area can be determined. Right? That is what we need to do. Now, using a vernier caliper, you have to find the external diameter of the tube now. External diameter of the tube. Right? Using the vernier caliper, find the external diameter of tube. This one. So let's assume that external diameter as D. If the external diameter is D, I'm going to erase this part. Look at the board. If the external diameter is D, look at here. If the external diameter is D, external diameter of test tube. If there is D, we know area is pi r squared. No? Area of a test tube is phi r squared. So this can be written as phi r should be D over 2 squared. Right? So that is phi D squared over 4. Right? So we can plug that value here. You can plug that value here. So rho is given by 1 over MA, but A is phi D squared over 4. Simplify this. Simplified value is 4 over phi MD squared. Now, M is gradient. So repeating again, M is not a mass, M is gradient. Right? So if there is like not clear, you can make this M dash. I don't mind. M dash, right? Gradient M dash, M dash, M dash, M dash. Now m dash is known, gradient is known, d diameter is known, phi is a known value, that's a constant, rho is a constant, then a calculation can be done and rho can be determined. That is the end of the experiment, right? So there are a few things to be understood. Okay, now after taking down the graph, mention everything up to this point, and with that note, mention this thing also, right? Mention this thing also. Can see? Exam. Finished. Right? That is the end. To measure this, we need a vernier caliper. So in the materials, mention vernier caliper. In the materials, add vernier caliper to the material list. Vernier caliper. Right? So you can use external jaws of the vernier caliper and measure this and find A. To find A. Okay. Right? Understood? So that's it for the experiment. And as the last heading write down, remarks / important points. Remarks / important points. Remarks / important points. Remarks / important points. First one, remarks. Remarks / important points. First one, iron balls should be filled into test tube. 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 Filled into test tube. To make it stable, when floats. To make it stable when floats. Right. Next point. Second point. Entire curved part of test tube should be filled. Entire curved part of test tube. Entire curved part of test tube should be filled. Entire curved part of test tube should be filled with wax. Entire curved part of test tube should be filled with wax. Right. Okay. So that is the end of the 5th practical. Right. Any questions? Anything to clarify? Now today, starting from the morning, now we have discussed all 5 experiments we have in mechanics. Right? Any questions? So we have discussed all 5 experiments. in mechanics, and now hereafter, now I have mentioned the past paper questions that have been already appeared from these experiments. So you can try those questions as well, right? Okay. Now, sir, can you tell about the study plan for 26 and ongoing paper classes before ending? For the details of paper class and everything, please join to the channel, because paper class is happening on Saturdays. So I'll be sharing that details on today's Friday, no? Yeah, tonight. Tonight I'll be sharing, right? So paper class is there. It's on Saturdays, 7 to 10. And for the study plan, it should be a weekly plan, and if you have allocated minimum around 8 hours a day, if you are 26 students, that is a workable plan. Minimum 8 hours among all 3 subjects per day, which means 56 hours a week, right? For now, that will be enough, and it should be increased along the journey, right? Yeah. So for all other updates regarding classes, seminars, and everything, yeah, usually it will be shared in the channels. Yeah. Now, what about the holiday? Was it productive? Huh? Online students? Consistency for 27 batch, any idea? I didn't get it. So what's gradient? What is gradient? 4, 5 square. That is coming from here, area. Not the gradient, that's the area of test tube. Yes, okay. Okay then. Right. So then, yeah, I hope you understood all the experiments we discussed, and you got something out from the discussion. And please try questions, because now, even though if you understood these experiments today, if you didn't try question patterns, again these things will be forgotten, right? So therefore, before these things are forgotten, try few questions and see whether how good you can answer, right? To which level you can answer. And I don't mind if you check with the marking scheme once you have finished answering. That's also fine. Okay then. So I have to start the next class at 3:30, 27 theory class. If I'm in home, I won't do nothing when it comes to holiday, but today I can't believe I have worked a lot. Very good, very good. I'm happy to see your feedback. Okay, very good. Right. Okay then. Yeah, I'm also rushing to the next class, because I have to go out and have my lunch before the next class that is starting at 3:30. And yes. Okay, then now if you have understood the lesson, whether you are on Zoom or YouTube, that doesn't matter. Once this live stream is ended, you can go to the live stream and add a comment there, because then that comment will stay forever, and I also can check the comment later on. Otherwise, if you put that to the live chat, it will be disappeared, right? For the students who on Zoom also, after the class in a free time, just go to the video there and add a comment whether you understood these experiments and whether it was an advantage or it's a benefit. It was a benefit for your journey. Yes. Any other things? All right then. Okay, then that's it for today's seminar. Yeah, that's it for today's seminar. I'll be winding up here. Yes, see you all again in another seminar or in the class, right? Goodbye, go safe, stay safe, and study hard. Goodbye.